Enough confidence in the things that I know. I have enough wisdom to see the logic will be shown. I got one chance to show you what I got. I got one chance to show I'm confident or not. Self-evident reason, deductions and conclusions, and the fools are running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance, show me what you got. You got one chance, show you confident or not. Don't get caught in the matrix of all of these fakers. Society's spinning, and I'm just here living on the ground. Self-evident reason, deductions and conclusions, logically thinking, and the fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. Shrinking in the distance, you can do fuck all with an angle, and the fools are running away.
Exactly. Oh, I didn't get any of that malarkey over here.
And
Oops.
we are live. Welcome everyone. It is Thursday, Euclid night. But I think
Not me rambling on. Sorry, I'll shut up
it's
now.
all right. It's all right. Carry on if you want. Have a chat. We're just wrapping things up at the end of this. So I'm going over some stuff. I've got some. Blue Marble's been chatting. He likes to talk. I'll explain all that in a bit. So what we're doing here is over these last few weeks, finishing off to the big April Fools. Oh, that'd be good, wouldn't it? Wrap it up then. So trying to give you an idea on the journey that we've been on. There's been a few of us on the journey, but the reason we came in here and all of the stuff that's gone on since we came in here to this arena, a lot's changed, and there's a lot of people have got well, I guess they've built up some sort of a ridiculous idea of what we're actually doing here. They've got no idea. They've never been to come and talk to us about what's going on. So they've made up this idea. So I'm trying to get people into the journey that we've been on. And a lot of this is generated by the people around us at the minute. They sort of, well, they give us places to look at and make us curious. I guess there's a lot of people within this arena, community, whatever you want to call it, little dark corner of the internet, that ask questions, and there's people that don't like being asked questions, but they do ask a lot of questions. They never answer questions. They don't like being asked questions, but they do ask a lot of questions. So let me get this.
Good afternoon.
Yo, Rob, that was some shitty mic, that.
I always have a shitty mic. I'm sorry. I got a new set of headphones, and they're no good. What do you expect for $20?
And I will be going over some of the old videos that we've been going through, because there's a lot of people that have been with us when we've been out on, in the field doing stuff. And then there's people that haven't. They've not seen all of the stuff that we do. So we'll go over this stuff first. Let me get this. I've got a couple of videos I want to go over. So again, this is going to be flitting about, hopefully bringing topics for conversation in other places other than this. I mean, it's not just what we do here. We do it and we talk about stuff, but I think there's a few people that watch and listen in that they get conversation out of it as well. They get to learn stuff as well. So that's good. That's why we do it. Let's see now. This is a conversation. Yeah. Throw that over there. So this is a series of conversations that Blue Marble did this. So this is on a video, I think from yesterday or something. Wednesday. Yeah, it will be from yesterday. So Wally comes on and he's desperate for us to go over some video of his. And I'm not subscribed to Wally. And to be honest, he's been in here and he seems like he's troubled mentally. So, I don't tend to take on those sort of people anymore. And he's made a video and he wants me to go over it. But, I mean, I'm not really interested. I don't think he's quite right. And I'm not interested in that. So I say, I'm not subscribed to you, Wally. Stop begging me to watch your videos. You sound desperate as fuck. Blue Marble comes on afterwards and says, I think you're the guy that sounds desperate, Bev. A 3.5 hour stream with 174 views? You should be really desperate. Oh, you really should be desperate. I mean, I don't know why. It's not as if loads of people have ever watched us or anything. And like I say, Spot On says, aren't you one of the ones continually in the text chat? And Create Belief says, and you seem to never miss one, Blue. So if you're out there, Blue, this one's for you. Starting the show off just for you. And wisely so. It's better than listening to logic, right? Stefan says, what logic? If the starting premises are incorrect, the proposition that forms the basis of an argument or syllogism, the conclusion drawn will be in error, even if the logical validity of the argument is in function of its internal consistency. So Stefan seems well up on the logic, which, I mean, I commend him. I guess he's learned a lot. Yep.
Hey, Bev, I know I got a really shitty mic, but I just wanted to say, I don't think these shows were for Blue. I thought they were for me.
Well, no, this beginning bit's just for Blue, because he does like to get a bit of content out of it. And like he says, there isn't many people watching, and he should be happy about that, because there isn't that many people that are interested in seeing the bullshit that Blue Marble Shine speaks about. It's good for us though, because I've learned a lot, and it looks like
Yeah, me too.
Stefan's learned a lot about logic there as well. I hope other people have too.
Yes.
And I say to him, is it the premise that all horizontals are parallel to the plane of the horizon, or that level is an equal elevation, or that a horizontal plane has zero slope, and as such is also an even altitude? Which premise do you deem incorrect? Me talking to Stefan. Again, I don't think he ever answers it. And then this is me to Blue, right? I say I don't do this for blues, blue marbles. I don't do this for views, blue marble science, which I don't. I do this because people misrepresent what I say and smear my name with lies. Not just me, actually, or everybody that's here. Smear my name with lies and slander. We do this so people can see the lies told aren't true. People like you should be ashamed of themselves, but you don't care about truth. Your religion makes you a horrible person, Blue. Be at peace with your globe. And I'll stand by that.
Man, Bev.
Stefan says, again, this is just words and definitions. We are supporting valid empirical measurements given evidence. They've not. They've never done anything. See, he says, so this is the evidence. This is what you have to give evidence for. This is Stefan Mudd, a guy on the YouTube comments telling me that I have to give evidence for it, right? So any citation to any empirical measurements supporting or confirming your claim. Right, now just remember, I've asked him which is the premise that's false. The premise that all horizontals are parallel to the plane of the horizon? Well, that's not hard to give evidence for, again. Or that level is an equal elevation. Or that a horizontal plane has zero slope and is such also an even elevation. No rise over run. He hasn't given us which one he says is incorrect. But he says that I have to provide evidence for those facts. And I don't know about
this is not validating premise.
So I say to Blue Marble, you sound troubled, Blue. You should be at peace with your globe. How strong is your faith? If you could state what your claims about the geometric truths and basic logic are precisely, so we can hopefully fix the problems you have understanding them. Blue Marble. I wish I could do his voice. I can't really do it. A guy that literally chokes trying to say the words sun, moon, or stars, and has to call them by the relictard reference. Religitard reference of lights in the sky isn't, well, they are lights in the sky, right? Isn't likely to be capable of potty training a child.
He's trying to say religitard.
Oh, religitard. By a religitard.
Like a religious, yeah, like a religious retard. A religitard. It's a Nathan Oakley thing, I think.
Oh, is it? Yeah, it makes sense. Blue Marble Science sounds a bit like Nathan Oakley. Okay. I've never even heard of that word before, so sorry, Blue, if I couldn't speak your words that you've made up. Or maybe you've got it off, Nathan Oakley, I don't know. Isn't likely to be capable of potty training a child, much less offering instruction in geometry or logic, Bev. I mean, I don't know if anybody knows what we do here, but I mean, I don't give instruction on anything. Everybody gets a chance to do everything for themselves. He says, I don't know what you should be at peace with your globe even means. Are you talking about the one on my desk or the one I live on? The little one on the desk is in fact mine. The big one belongs to all of us. So maybe you need to be at peace with that one yourself. Well, let's let everybody know. A globe, to me, is your own personal construct that you think that you live on. And that's fine, because it's axiomated, 'tis globe. It just is a globe. Now, what you imagine that globe to be is whatever you want it to be. It's your globe. It doesn't belong to everybody. It's a personal thing, Blue. Completely personal to everyone. And then we get into Stefan Mudd says, fascinating to listen to your response as you got a citation for measurements of the spherical earth you demanded, Bev. Laughter and ignoring. Well, I think I asked because, Stefan, you said you could easily measure the radius. And I said, please tell us how you measured the radius. And once again, you did not give anything. And then he says again, but when asked to support your positive claim, all verticals are parallel. But I don't think I've ever made that claim. I mean, I have made the claim that all horizontals are parallel. And I have made the claim that all horizontal planes are parallel to the plane of the horizon. And I have made the claim, obviously, that all perpendiculars to a horizontal plane will be parallel. And I have made the claim that horizontal and vertical are perpendicular. But I don't think I've ever claimed that one. I think that's, he's just put that in inverted commas because I don't think it's true. Suddenly, after this shift in the burden of proof, right, well, I've never claimed that, so. And then I say, all verticals are perpendicular to a horizontal plane. You can't show a black swan to prove this statement wrong. It's your claim. This is a false statement. If you claim this statement, all verticals are perpendicular to a horizontal plane, is false, then you should show your proof of falsification or show your proof by contradiction for the statement to be false. Proof for verticals to be perpendicular to a horizontal plane is an easily measured right angle. You can do this yourself. Why do you say you require me to do this? Are you not able to prove the perpendicularity of vertical and horizontal for yourself? What do you reckon this answer will be? Deflecting again. Where are your valid measurements giving evidence for two or more horizontals which are separated by distance are parallel? So he doesn't think he has to do anything. He just has to say, nuh-uh, you can't prove that to me because I haven't got a proof system. I don't know what logic is. I don't know how to prove it. So anything you give me will be denied. That's Stefan Mudd. He's part of the Blue Marble scientific community. The science of the not that. And you can quite clearly see he's saying not that. He says, now it's your turn to show empirical measurements giving evidence of all horizontals being parallel at different positions on Earth. All horizontals are parallel. It's a known fact. You've just got to put it on your globe. Be done with it. It's a contradiction, right? 'Tis globe. Horizontals are parallel. Sorry. I say, I will supply any elevation profile ever drawn. You've been shown multiple elevation profiles of canal designs and actual design specifications for these elevation profiles, with the tools and methods used to measure for these profiles. You and your blue marble science buddies just bend them, a la Chaiki, in a debate at Blue Marble. So it wasn't a debate. Chaiki didn't have an argument, but Chaiki just bent it, right? Your sophistry is out in the open for all to see. You ask for something that you yourself don't even believe exists. Be at peace with your globe. Stefan Mudd. Elevation profiles based on the geodetic datum. Funny how the datum is based on a spherical Earth. Did you forget that, or did you claim the geodetic datum is flat? Why does he use that? Who uses that word? I'll tell you who uses that word. Flat Earth Society. Stefan must be Flat Earth Society.
And he's changed the topic of the conversation now.
Yeah. Right, look, he has got it here, right? He's got, in this bit that he's put, a horizontal geodetic datum may be local or geocentric. If it is local, it specifies the shape and size of an ellipsoid. A horizontal geodetic datum. If it's local, it specifies the shape and size of an ellipsoid. A horizontal datum.
No, it doesn't.
Well, that's what he wrote down here. I mean, it must be.
This is false implication.
Well. And then I say to him, have a look at any elevation profile to see parallel horizontals. Thank you. That's a thank you, that Blue. Stefan Mudd again, Bev. The elevation profiles are based on the geodetic datum, which is based on a spherical Earth. Mean sea level is the datum for measurement of elevation. Mean sea level is the equipotential surface of the Earth, as described by the geoid model WGS84. So how does your elevation profile argument support your claim? What elevation profile are you referring to? Orthometric, ellipsoid, or geoid height? I'm talking about, I'll tell you now, any elevation profile you want to put your hands on. It will have a horizontal baseline. All of the horizontals on any elevation profile will be parallel. Any, every, all elevation profiles. That's what I'm saying. I mean, we could go into the maps and the plans and stuff like that as well, but I mean, it's a little bit difficult for them to imagine that. So, here we go. Blue Marble Science. It's coming back. Stefan's not doing well enough, so Blue comes in to help him and says, parallel elevations, Bev. Not parallel horizontals. Find one of those drawings labelled as horizontal profile. We'll wait. While you're at it, tell us what scale on the y-axis is measuring and what it's reference to. Parallel elevations, Bev, not parallel horizontals. Well, no, I'd say all of the horizontals on an elevation profile are parallel. That's what he asked for, and I showed him. He can get anyone. He can get it for himself. There won't be any trickery done. You go and get it. Much easier than Googling. You don't want to be trusting anything that I give you. You'd never trust anything that I give you. Go and get it yourself. So Blue's doing a word switch here. Playing semantics. I said horizontal parallels, and he's talking about labelled as a horizontal profile. What's that? Did you get a profile of a horizontal? Is that what he's thinking?
So horizontal needs profile.
What would a horizontal
Strange.
profile look like? I
Like
bet
horizontal?
it would look like a horizontal line, wouldn't it?
I think the first statement he makes is an interesting one. Parallel elevations. I see two different ways of interpreting what he means. I don't want to put words in his mouth, but a horizontal plane, every point along a horizontal plane is at the same elevation, aka it's the same thing he's talking about. That but not that here in this case. But elevations are measured in the vertical, perpendicular to horizontal. So if you flip it that way, is he saying parallel verticals? I mean, I know he's not, but you could interpret it that way if you're coming from the outside reading this.
Yeah. Well, all perpendiculars to the horizontal would be parallel.
Yeah.
So I guess, I don't know. I guess you're better speaking for Blue Marble because he won't speak for himself. He likes to do
I don't
this.
want to speak for him either.
And I said, the plan is the horizontal profile, Blue. Because I knew what that'd do. And then Blue Marble says, a surveyor or guy with a certificate in surveying should know that plan views are top-down views, Bev. They are not profiles. They are not sections. They are not elevations. They are plan views. You made an erroneous claim that elevation profiles show parallel horizontals, and they do not. An elevation profile shows parallel, wait for it, elevations. That's why we call them elevation profiles.
And these elevations are parallel. It means that verticals are parallel. Simple.
Mm-hmm. Perpendicular to it, yeah?
So
All
Blue
of them.
Marble is flat earther.
I don't know. I think that's a swear word, but I mean, yeah, he might well be flat Earth Society. He says elevations are not horizontal straight lines. They are all arc segments of a circle with radius of about 6,400 kilometers. Since the only information an elevation profile conveys is height above or below a datum, like sea level, it follows that we can represent that information on a simple XY graph. I'm surprised you weren't taught these things in your class, Bev. You should really look into what you could do to recover any costs you incurred for that course, as vital information was either withheld or misrepresented. Blue Marble, talking about parallel elevation profile shows parallel, wait for it, elevations. Here it is. Look at that. Elevation profile. This is Blue Marble Science. That's why we call them elevation profiles. Elevations are not horizontal straight lines. They are arc segments of a circle. What's one of the requirements for parallels? Anyone know?
Straight line.
Straight.
Straight. So How can elevation profiles show parallel elevations and then elevations not be straight lines? Isn't that a bit of a contradiction? Yeah. Spotted a contradiction there, Blue. Don't worry about it, though. Your model's full of them. But that was you. You wrote that, Blue. Nobody did that. I mean, that's half of the reason we go and we do this, like I say, is to document this sort of stuff. So it can't be forgotten. You wouldn't want anybody misrepresenting you or anything, would you?
Then there's a new contradiction coming up right after it as well. Let's see. Elevation profile conveys is height above or below a datum. It follows that we can represent that information on a simple XY graph. Well, those are two perpendicular lines.
Yeah,
the
XY.
axes.
Yeah, they are straight lines.
Straight lines, yeah, not arc segments of a circle. So there's your second contradiction right in a row.
That's the elevation profile, right?
Yeah.
It's like that's a double switch, right? From one to the other and straight back again. So you never notice the difference. You can carry on talking about normal life. So I say to Blue, I say the plan is a top-down view of the horizontal plane, Blue, as opposed to the side elevation, which is a view of the vertical plane. Think we agree, Blue? I mean, I don't know if anybody knows. I think Blue was meant to have been an engineer. I think that's his character, his story behind his character is about him being an engineer. Now, everybody knows what elevation at least if anybody's ever worked in construction or anything around construction, art and design or whatever, you would know what a side profile, elevation profile, plan, isometric drawings, you'd know about all of that. You've never been shadow banned, Blue. Stop moaning. He's there crying in the chat as well. Bloody hell. So yeah, anybody that's ever done that should know this sort of stuff. I don't know what Blue Marble's talking about, other than wanting to contradict himself and show everybody his contradictions. And Stefan Mudd says, sideways like orthometric height, ellipsoidal and geoid height. He's obsessed with it. Telling you, this is flat earth society sort of shit. We're talking about elevation profiles as used in reality for construction projects, buildings. I don't know what he's talking about. Blue Marble, you just said, talking to me, said, you just said the plan is the horizontal profile, Blue. Did you not? There is no such thing as a horizontal profile, Bev. The very definition of profile is a side or sectional elevation, such as a drawing showing a vertical section of the ground, a vertical section of soil from the ground surface to the underlying weathering material. That's from your surveying textbook of choice. Merriam-Webster. I don't know who told him that. But nice one, Blue. He's been looking up. See, Blue Marble looks up stuff. Now, back to my original point. He says, but elevation profiles do not show parallel horizontals. Although all of the horizontals on an elevation profile would be parallel. Obviously. Elevation profiles show elevations above or below some datum. And that datum is represented as a horizontal line on a graph, irrespective of the actual shape of the datum. Is he saying that the actual horizontal lines on an elevation profile are all parallel? Is he agreeing with me there? In a roundabout way, but now having to go against it. So he's saying that the lines that are shown in elevation profiles are indeed horizontal, but for some reason they're different. They're not that, right? They are horizontal, but they're not. I'll read it again just to make sure, right? I don't want to misrepresent you, Blue Marble Science. So we'll go over this again just to make sure we understand what Blue Marble is talking about. That's Blue Marble Science, the actual YouTube character. He's not speaking for the entire body of the mythical science Blue Marble. He's not talking about that. So now, back to my original point. This is his original point. Elevation profiles do not show parallel horizontals. So they don't show parallel horizontals. Elevation profiles show elevations above or below some datum, and that datum is represented as a horizontal line on a graph, irrespective of the shape of the datum. Really? So now you know. All of the elevation profiles will actually have parallel horizontals, but Blue Marble says that it would do that irrespective of the actual datum anyway. So although all of the horizontals are parallel, Blue admits to it, because I said all horizontals will be parallel and shown on an elevation profile, apparently they have to change. Right, so I'll read this again because this is quite important, and this is Blue Marble Science and how he communicates his scientific. This is the rhetoric of the Blue Marble Science. Now, back to my original point. Elevation profiles do not show parallel horizontals. Elevation profiles show elevations above or below some datum, and that datum is represented as a horizontal line on a graph, irrespective of the actual shape of the datum. If it were an actual scale drawing of the shape, it would be called a section or a view. You seem to be intentionally attempting to mislead people with word tricks, Bev. Why do you do that? Anyone notice the word tricks? I don't know. I'm not aware of them. Somebody tell me if I'm performing magic trickery. Is Blue right that I'm trying to mislead people with tricks? I mean, I'm open here, right? Unless I'm doing some extra special trickery that, you know, I'm opening up to criticism, commentary, whatever that. Anybody want to check my sleeves? I'm just saying that elevation profiles, every elevation profile will show parallel horizontals on it. All of the perpendiculars to it will be vertical on every elevation profile ever drawn. Any architect, any draftsman, anything like that. You could say a plan. Every plan is on a zero changing elevation. It's on one elevation. That's your plan. That's your base. And that's horizontal. You could do topographic. Terrible. But I mean, this is Blue Marble Science, and this is, you know, this is about the best that they have, I think. And then I say to him again, all elevation profiles show parallel horizontals opposed to the perpendicular heights. The plan will show a horizontal section with zero elevation change known as a horizontal plane. This plane is the base for all two-scale maps, or the XY plane, as you may want to call it. And I must have said these sort of things many times, but I think I'm getting a bit more concise. Gets a bit easier to say all of this sort of stuff once you've said it 1,000 times to Blue Marble scientists. Blue Marble says, "That's just wrong, Bev." Says, like, just, nuh-uh, not that. Plan views are not sections. You either don't know what a section is or you're intentionally lying about it. Would you like to see some of my Cavendish drawings, where I draw actual sections and elevation views? See what he's done there? He's swapped sections and views. Doesn't do elevation profiles. He does elevation views. Elevation profiles do not depict horizontals, he says. There would have been no horizontals on Blue Marble Science's Cavendish. I can guarantee you that. That's right, Blue. Innit, Blue? No perpendiculars between horizontals on yours Cavendish drawings. I bet there isn't. Elevation profiles do not depict horizontals, says Blue Marble Science. They show elevations, and the elevations are reference to some benchmark for horizontal position and some elevation datum, which is a constant, like mean sea level or nav 88, the vertical datum. North American vertical datum 88. Again, mean sea level, same thing, vertical datum. Once again, you either don't know what an elevation profile shows or you're intentionally lying about it. Blue Marble, well done. This is good one. See, everybody's learning. Your ECV and flat model affliction are starting to show badly. Tell me, Blue. Tell me about my ECV. Come and have a conversation. Expose my ECV. See what it is that I can't talk about. Come on. I dare you. Elevation profiles do not depict horizontals. I bet anybody would be able to show you a horizontal on an elevation profile, Blue. Anyone? Stefan Mudd then explain orthometric, ellipsoid and geoidal height in relation to verticals. This here is what we call a subversal, where he starts to ask you what it is you want to see. Is that it? Is that the end of it? 3 minutes ago. Let me just check just to make sure. John Holland, who's this? There we go. John Holland, newcomer. Welcome, John. Says, I can't believe you don't understand elevation profiles. Me. If you were given a wheel with an inflated tyre from a car that had experienced a high-speed lockup and you have to measure the tread depth at 10-degree intervals around the entire circumference, then represent the data as an elevation profile. What was your graph look like? Did we have somebody who was doing graphs the other day? We got a graph specialist over there in the Blue Marble Scientist graphage. Was that Darren? It might have been, mightn't it? Wonder if John Holland's a Darren sock. want to say that. Is Wally trying to tout a bit of business? Go back to Discord for a bit. Well, let's cue this up. Okie dokie. Let me find this. You might like this one today. Right, this will be a quick one, and then we're going to go to do tangents. Should we do tangents first? See this one. We was going to go over this one, but we might do it tomorrow. In fact, I'll just get this on a... some of the... This is his procedure. You might be able to see what we were talking about. This is all of his equipment that he's got. This is a guy who may or may not live in Maine. And we'll get round to some of the other stuff that we've got to do. But can you see this? Read that up there.
And we come up with 90, 10, 48. But the seconds varied from 43, 52, 10 minutes, 41 seconds. Then I flopped the scope.
There you go.
I did this all in southern Maine. I'm not telling you what town because I don't have to. I just don't have to.
He may or may not be in Maine somewhere.
So on the left page, it shows a triangle with a dot. That's the survey symbol for control point or occupy station. I was on 402. My rod height is next to that at 4.94. This is all in feet. My back sight was 404 with a rod height of 509. You see my horizontal distance, vertical distance, and slope distance that I shot over there.
Horizontal distance, vertical distance, and slope distance. So they're the three distances he's got. Sort of like a triangle. Horizontal, vertical, and slope. Obviously, rise over run. So we have a horizontal distance between the two of them. And look at the distance there.
But the horizontal distance and the vertical distance are calculated by the total station. Sometimes I say gun by accident. It's just a way that surveyors talk. It's flying. So the slope distance is what matters because that's what's actually shot on site. So I'm going to use that to calculate later.
So he's going to use the slope distance because it's the tool that actually measures the slope distance. But can you see what that slope distance is? It's 1,252. Yeah, this is good, this, isn't it, Blue? See that distance there? It's about, what's that? 500 meters-ish? Something like that. Bit less. And can you see these measurements that he's made? That's right. To the arc second. How does he do that? How does he manage to do that? It's good, isn't it? I'll just go back to the Discord. We'll go over that at some other time. I'll just sort this video out. I've got a few. There's a wait a minute. Right, there we go. You guys can see that. Did you see that switch then? Let me put this back over here.
Yes.
Okay, now this is a video that I've found on, let me do this, on Jesse Kozlowski. Can you guys see that? There you go. That's a bit better. Earth radius measured without angles by Larry Scott. This will come in important at a later date, because I don't know whether you're living or you're aware of some of the people. Larry Scott has a method that Jesse Kozlowski uses. He uses the Larry Scott method. And now this is also, we're linking these people together, because you remember the other day when we went over Jesse Kozlowski, and he did say he was with Jesse. So we're linking. There's Jesse, Larry, and the main surveyor in this particular video. I found this today on Jesse Kozlowski's channel. Right, you can see this. This is another one that he did of a video, a 1 mile level line, and in which he has a horizontal and a horizontal looking forwards and backwards. So he does that. So you go back into this one, but this is one of the crazy places that you'd expect to see a world-renowned surveyor with a method for measuring simultaneous, collaboratory, to record
Scientific
observations.
method.
Yeah, Jesse talks about it. I'll have to find it. I mean, we are going to go over all of this sort of stuff, because these are the guys. Obviously, when we say elevation profiles have parallel horizontals on them, well, Blue Marble says no, not that, because of people like Jesse Kozlowski and Larry Scott. So they're gonna I'll let you go over this one here.
Yeah, I want to see it.
It's a bit bad.
And which one's going to be higher? Well, I just put this together the other day for which I thought was pretty germane to what you're all saying just now.
Bad.
And you may have seen this before. This is the Maine surveyor up in Maine. Jesse Kozlowski went to Taganak, New York. I went to Hagerstown, Maryland.
3 of them.
And these 3 points are a section of Great Circle. And I had messed around with angles to the sun, and of course, people like Lemon and Chris Berry, whatever, they say angles don't mean anything. So let's ignore the angles.
No, the angles.
So let's just measure the distances. Now, measuring distances needs a little proof that you can measure a distance, I guess.
Can you guys hear that? I mean, this sounds really bad. It's on Jose's, and I think Jesse's took it off that, so I don't know whether it's even bad. But can you guys hear that? Is that okay for you? I don't want to ruin Larry's presentation, but this is measuring the radius of the Earth without angles, angleless radius measurement. Is good. Have you ever heard of this? Of a method? Have you ever heard of the geometrical method of measuring distances? to find the radius. Well, watch and learn. Larry Scott, he's a master.
So this is a classic, typical total station. My very cherished massive array of retro mirrors, much like it's on the moon. And I vacuum measure distance, just a pure laser ranger distance. We all like lasers, don't we? And here's an older model, does the same thing, just measures distances. Nice, very old retro mirror. And then I have this. I
Just
have two
measures
GPS
distances.
antennae and two GPS receivers. Now, when I talk GPS measurement, I am not talking about what you get on your phone, what you get with your handheld Garmin. I'm talking about recording the full radio signal from 10, 12 satellites all at the same time at two different locations. So when you measure...
You're right. He's measuring it GPS and the laser range finding things.
Hang on. Can I say something?
Yeah.
Anytime we hear them say satellite, we correct them and we say balloon.
The ground, the base stations.
You know, but when they say satellite, they're thinking something up in a vacuum of space. I will just tell them you're looking at a balloon.
Well, I mean, like a globe, you can imagine whatever you want, right? Satellite conjures up an idea in people's minds. That's fine. 12 of them he has. How would you use a balloon as a range finding thing? A distance? I don't know. I wouldn't know. Triangulation, lane. I know how to measure something, but this sort of stuff's fancy as anything. I mean, look at it. Look at all the equipment he's got.
When you record the signal independently at one receiver and independently at a second receiver, the two receivers are not interacting. They're just recording data, and those two data files are brought together in software. And
You like that? I mean, look at that. 25 grand in 1998. I don't know whether it costs more or whether it's an antique or whether it, you know, like you can get them cheap now. I don't know if technology is how it's worked, but I mean, whew, that's impressive. He's got two of them.
the total station just uses a laser ranger, 872.358, just about a half a mile. Easy peasy, everybody does it, ubiquitous. If I take the two data files from the two GPS receivers and just extract the distance between the antennae, I get to the millimeter the same answer. So if somebody says, where's your evidence? GPS, you can extract just a pure, simple distance between antennae. Now, this is a total station. Total stations sometimes have built-in electronics and corrections. All right, but if you know anything about them, you look at that little triangle icon, you see this is just the unadulterated slope distance mark to mark, much like this, which also happens to be identical.
Slope distance.
Now here's my older instrument, which has no such curvature capacity built in. You can see on here a beautiful 1977 manufacturer's label, and it gets the same millimeter. All right. Now, when dealing with
78.
A to B measurement by GPS, line of sight doesn't mean anything.
Did he say that? Did that show the calibrated? It was due for calibration in 78. Was his old one.
The receivers record data independently without any interaction between the receivers. They're strictly, purely independent. So I measure a distance from A to B, and I measure a distance from A to C,
Okay.
C to B, and B to A. Oops. Now, if you look at this, these three distances, this is Hagerstown, Titanic, New York, and Lakefield. Those 3 points are in a straight line. But you notice the distances overlap. The distance from Alpha to Charlie, Charlie to Bravo, added together are longer than the simple distance of A to B.
You get that? It's in the distances he's measuring with this stuff. Did you ever know about that? To the millimetre. Look at them. How accurate are they? These guys can actually do this to the millimetre. I hope you're impressed. It's 452.68 meters greater. When you measure from A to B, and then you measure from A to C, and then C to B, you can't be doing it on a map, right? Because it wouldn't work if you were doing it on a map. But what he's saying is, if you put the GPS things in the positions that they are on the map, then it doesn't work. I think that's what he's saying. Anybody else got any ideas? Seriously, nobody's got any other ideas of what Larry's doing here. So he's got like a map, right? And this is a map in America, I presume. So you go from A to B and you measure it. And then you go from A to C and then from C to B and you measure it. And they're different. Okay.
If you have a straight line, A, B, and a point C in between somewhere,
Yeah.
and you measure first AC and then CB, that will be the full length AB. There's no way around that.
You'd have thought so, wouldn't you?
Yeah, so this is some sort of magic going on here that he is laying on you.
Yeah. Yeah, I mean, look at those distances that he appears to be able to measure. I mean, is that 838,000 meters? I mean, that's a lot. I mean, like, that's some good equipment for measuring to the millimeter. To the millimeter. Fantastic. And you think he had to do this on Jose's? You'd have thought he'd have got somewhere better for him to do this. Let's have a go. I don't know where he was. Jesse on one of them, the guy that may or may not have been of Maine. He might not have been in Maine when he did that.
450 meters. 450 out of 838,000 doesn't sound like a lot. Actually, it is. And when you take those three lengths, you end up building a triangle. And so we get Hagerstown, Titanic, and Lakefield. Notice the...
Okay, so we've now made a triangle on a straight line.
Yeah, that was his words, weren't they?
Mm. Yeah,
they are on the same straight line.
Mm-hmm.
Yeah.
Except it's a triangle straight line now. Triangular straight line. Well done, Larry. Nobody's in there, Blue Marbles. I mean, who's he got? Oh, Blue Marble is in there. There he is. In the chat. All right, well done, Larry. Well done, that man.
Now, the triangle have 3 points. 3 points can also define a curve. And that's when we end up with this.
Mm-hmm.
Now,
3 coplanar points, right? They're on the same straight line. So 3 coplanar points could define a circle. So it's pretty familiar. There's his triangle.
you build that triangle out of those 3 distances, you notice 3,000, you end up with 3 isosceles triangles. Triangle on the left, which is AC in the center of the Earth. The triangle on the right, which is CB in the center of the Earth. And then the big isosceles triangle of AB in the center of the Earth. And notice here, by the simple, and this is high school trig, no angles, hardly, just distances. You notice the distance, what happened? The distance to the center of the Earth, 39.58 miles. 39.57 and a quarter miles. 39.56 and 3/4 miles. These 3 points in Hagerstown, Taghannock, and Whitefield are all low elevation. This is not on a mountaintop.
Where did he get those from?
Well, all he did was measure 2 distances, he says. And it's therefore 3 collinear points, he also said. So all of these triangles he has conjured up out of nowhere. I mean, he better do some better magic in order to, explain how he got those out of 3 collinear points.
He's drawn a triangle, right? I can see that. He somehow measured point C as being in the middle of a straight line, but distances were strange. So he decided to plot it in an elevation profile and ended up lifting the middle one somehow into the top of a triangle. But I mean, this is called Earth's radius measured without angles, but he's drawn a triangle. And then where did these radiuses come from?
Mm-hmm.
Like, where? He's just got a triangle. How did he do that? How did he measure that? He just wrote it out.
Yeah, no measurement required. He said 3 collinear points. He then made a triangle. This feels like Rumpus when he just draw a circle. Well, just make a triangle. Just add in these other lines to make these other triangles. But yeah, those line distances that goes off the page downwards, they are gotten from somewhere else, not from the 3 collinear points that he measured.
What, Blue, you said it. He said it was in a straight. Blue saying they're not collinear, but they were on a straight line.
He said Larry Scott said they were
on a straight line. That's collinear, Blue. What are you talking about?
Yeah, I'm just going by what he said.
Yeah, that's me too.
Yeah. Like, pictures can be deceiving. Everybody knows that. Go by the words that he actually said.
He's even measuring these. I take it these things measured distances in straight lines. Or did you start off with 3 points on a straight line to find out that they weren't on a straight line once you measured them? Is that... Right, let's go back in and let's get this. Pick it back up again. Was it there?
In Lakefield. Notice the triangle. Now the triangle has 3 points. 3 points can also define a curve. And that's when we end up with this. Now, if you build that triangle out of those 3 distances,
see, look,
we get Hagerstown,
you have a triangle.
Titanic, and Lakefield. Notice the triangle. Now the triangle has 3 points. 3 points can also define a curve. And that's when we end up with this.
Boom! Look at that. Bam! And bam! 3 points can also define a curve. And bam! Here we have.
If you build that
It's there. It's got the radius on it.
You notice.
It just did that.
3,000. You end up with 3 isosceles triangles. Triangle on the left, which is AC in the center of the Earth. The triangle
is AC center of the Earth. Is that an isosceles?
Well, he's got 3 isosceles here. But like, I will agree that once you have a triangle, you can find a point that would be the center of the circle whose circumference would pass through the 3 points of the triangle. Of course you can do that, but you're gonna need a triangle first. And he said these were 3 collinear points. Plus, it's only arbitrary that he's done it this way. He could have put the triangle the other way on the underside of the horizontal just as easily, because it's all a magic trick, obviously.
You see, this is A to B, and that's 8382331.754. Yeah?
According to the diagram, yeah.
This one here, from A to C, is 419.342.397. And this one over here is 319.342. It's the same, but 0037. So this one's a bit smaller than this one.
So
that's not an isosceles triangle.
No, that's also true. Yeah. And another point to make is that the top left line here, which I assume is A to C, overlapping the other one, which is C to B. Well, the right endpoint of the top left line and the left endpoint of that right line, both of those endpoints are both point C simultaneously, which of course is impossible.
If it's a straight line. So what he started off with was a straight line, but he's found out that it wasn't a straight line. So his initial premise of starting out on a straight line is obviously false, but he's not correcting himself. He's gone along with part of that as the thing. He's falsified the fact that he started out on a straight line by the fact that he's either measured wrong distances or he wasn't on a straight line, right? He can't be both on a straight line and not on a straight line.
Exactly, yes. Because that point C can't be at the apex of that not isosceles triangle and also in the center of that long horizontal base of the triangle. Can't be at both locations at once.
Right, so if he's saying that this isn't an isosceles triangle.
Now the triangle has 3 points. 3 points can also define a curve. And that's when we end up with this.
Boom.
Now, if you build that triangle out of those 3 distances, you notice 3,000 100,000, you end up with 3 isosceles triangles. Triangle on the left, which is AC in the center of the Earth. The triangle on the right, which is CB in the center of the Earth. And then the big isosceles triangle of AB in the center of the Earth. And notice here, by the simple, and this is high school trick.
They're not
no
equal,
angles,
these.
hardly, just distances. You notice the distance.
All three of them are different, aren't they?
Yeah.
The distance to the center of the
Yeah,
Earth.
very good.
39.58 miles. 39.57 and a quarter miles.
They're all different radiuses.
39.
Yeah.
So of course,
and 3/4
of
miles.
course, from measuring 3 points, you can find 3 different radiuses. That's very clever, Larry. Genius. 1 for each point. Rather clever. Geometric ability Larry's got here.
These 3 points in Hagerstown, Taghannock, and Whitefield are all low elevation.
They're at
This
lower.
is not on a mountaintop. Taghannock and Whitefield are only about 100 feet above sea level, and Hagerstown is about 700 feet above sea level.
It's not higher, is
The
what he's
reason why
saying.
those 3 distances are different,
Despite looking,
because we're on a spheroid.
yeah. Despite
And
looking
so
like there's a difference in
The
elevation
radius
there.
that you get from that,
This is not an elevation profile that you're looking at. Isn't that right, Blue?
if you look at doing the full math, and you involve zenith angles to
It's
the
not
sun,
like a
you
slice
get
even through
on
it,
the
you know,
left,
like an
39,
elevation profile.
62.944, which is an effective
Well, he's
radius
got an angle.
of the ellipsoid
He said he'd do it without
for
angles,
that
but there's definitely an angle there on screen.
260-mile length.
Okay, so everybody all right with that? That Larry Scott can measure the radius of the Earth without angles from just measuring distances along a straight line. Go on.
This is new method
Yeah.
for sure.
You like it?
Since straight line is great circle, yes, it is good enough.
Yeah, so you can have collinear and not collinear at the same time for the diletheist. Jerry, this is
Yes.
Jesse Kozlowski.
Isn't it eerily reminiscent of how blue marble science's internal chord tangent plane also was a horizontal, yet was at different elevations at either side of the bridge?
Right, so this is all the way back 6 years ago. This is when Jesse Kozlowski started. So he did geodetic surveyor testing equipment. These you'll have to. I'll have to do with the ads.
Hello again. It's Monday, March the 7th, and today I'm out here in Maryland in Howard County
Got some new equipment.
to perform some instrument testing. I'm going to be using this high precision electronic total station instrument that measures angles very precisely and distances very precisely. And before we put this instrument into service on work, we're going to be comparing it to the lengths that are published for this calibration baseline. As you can see here, this is the 0 point set back in 1988
A 0
in
point.
this deep concrete footing. There are marks set at 0. This is the 0 meter mark. There's one set at 150 meters. There's one
Okay,
set
so
at
Jesse isn't
425.
messing about. Look, he's got
I am
all of
too.
this stuff.
Compare my results to these published lengths. And what this does is assures that this instrument's performing correctly. It's outputting results that are traceable to the
Lengths.
national length standard.
Length standards.
So we have a beautiful day here. It's Monday afternoon.
Right, so his equipment's for measuring lengths. Jolly good. What was else? The rest of it. How were geodetic datums established? You can watch all of this stuff. Do you want to see this? Because I don't know whether you're all aware of exactly how sea levels are. Because this is Jesse Kozlowski. It's only got 147 views, so I think we should big it up. It's a 3-minute 26. And it might show you the problems. I mean, like, you know, when I say a water level is a tool for establishing a horizontal plane of reference, I mean, that's exactly what I'm talking about. When I'm talking about elevation profiles having parallel horizontals on them. And that's the way they're drawn and everything. But I don't know whether everybody's aware of this, but I mean, check this out.
When you and a
This is
team
good.
are pitching a new product,
Adverts.
Grammarly's tone suggestions can offer a more
There's a lot
personal.
of adverts nowadays.
Sea level seems like a pretty easy concept, right? You just measure the average level of the oceans and that's that. But what about parts of the Earth where there aren't oceans? For example, when we say that Mount Everest is 8,850 meters above sea level, how do we know what sea level would be beneath Mount Everest, since there's no sea for hundreds of kilometers? If the Earth were flat, then things would be easy. We'd just draw a straight line through the average height of the oceans and be done with it. But the Earth isn't flat. If the Earth were spherical, it would be easy too, because we could just measure the average distance from the center of the Earth to the surface of the ocean. But the Earth isn't spherical. It's spinning, so bits closer to the equator are thrown out by centrifugal effects and the poles get squashed in a bit. In fact, the Earth is so non-spherical that it's 42 kilometers farther across at the equator than from pole to pole. That means if you thought the Earth were a sphere and defined sea level by standing on the sea ice at the North Pole, then the surface of the ocean at the equator would be 21 kilometers above sea level. This bulging is also why the Chimborazo volcano in Ecuador, and not Mount Everest, is the peak that's actually farthest from the center of the Earth. So how do we know what sea level is? Well, water is held on Earth by gravity, so we could model the Earth as a flattened and stretched spinning sphere, and then calculate what height the oceans would settle to when pulled by gravity onto the surface of that ellipsoid.
Did you hear that?
Which part?
I mean, how he talks really fast, right? Probably a thingy, but I mean, he says here you could measure the
Gravity, so we could model the Earth as a flattened and stretched spinning sphere, and
so you could model the Earth as a flattened and stretched spinning sphere. You could do. Probably, I'd leave that over to the Blue Marble science team.
then calculate what height the oceans would settle to when pulled by gravity onto the surface of that ellipsoid. Except the interior of the Earth doesn't have the same density everywhere, which means gravity is slightly stronger or weaker at different points around the globe, and the oceans tend to puddle more near the dense spots. These aren't small changes either. The level of the sea can vary by up to 100 meters from a uniform ellipsoid.
But did you ever wonder what that was?
I never
Those
heard
different
that before
colours.
about the density variation.
Yeah, that's what you're looking at there on the screen. Look, plus 80 meters, minus 100 meters. So if you're going downhill, right, if you're ever going from America in that direction, right, watch out for that 100-meter thing, because you're going to have to get back up it again to get over here. I mean, it's 80 meters above over here. That's a hell of a trek, that, uphill and water. But that's what he's saying there, right? The water would pool up.
Depending on the density of the Earth beneath it. And on top of that, literally, there are these pesky things called continents moving around on the Earth's surface. These dense lumps of rock bump out from the ellipsoid and their mass gravitationally attracts oceans, while valleys in the ocean floor have less mass and the oceans flow away shallower. And this is the real...
Did you see that? You see that?
Yeah.
He's got a hump. Because of the land. He's got a bit of a hump there. I mean, this is Blue Marble science. This is state-of-the-art stuff.
It's good. And then he has a hole in the water coming up.
Yeah, this is good, isn't it?
Gravitationally attracts oceans, while valleys in the ocean floor...
Valleys in the ocean floor? I never even knew that. It'd be like chucking a brick in and going like, what's that on the top of the water? Looks like a brick. Somebody must have chucked a brick in the water.
Floor have less mass and the oceans flow away shallower. And this is the real conundrum, because the very presence of a mountain and continent on which it sits changes the level of the sea. The gravitational attraction of land pulls more water nearby, raising the sea around it. So to determine...
Do you see that?
Water displacement
lifted the
fell.
water up. It lifted the water up with it. It went, mountain went, come on, water. You're coming with me, mate.
Determine the height of a mountain above sea level.
Look, he's got it. It's got two here, look. It'd be so good that you can draw this sort of stuff with crayons, isn't it? But thank God for crayons. I mean, how would you do it without crayons?
Should we use the height the sea would be if the mountain weren't there at all? Or the height the sea would be if the mountain weren't there, but its gravity were?
Hang on.
I don't know.
Hang on. Can I say something?
Of course you can.
Do you know that his gravity is out of date? Newton was superseded by Einstein. Gravity is not a force holding water to the earth.
No, it's the mountains. The mountains lift it up. But you have to imagine where the water would be if the mountain weren't there, or whether you'd leave the mass there and take the mountain away. It's hard work. Luckily, they just measure the sea level and mean it at the actual sea level, right? They don't imagine anything.
Do you think that? Do you think you went to the seaside once and saw the waves hitting the rocks and thought, "Oh, look at that! It's higher, isn't it?" Sometimes.
Yeah. Look at the rocks drawing the water to it. That water seems to be coming towards the seawall. That's because the seawall's higher.
Science is fascinating.
People who worry about such things, called geodetic scientists,
they worry about it. They're worrying. They're always worrying about such things. Look, is there look, here we go. This is fantastic.
So to determine the height of a mountain above sea level, should we use the height the sea would be if the mountain weren't there at all, or the height the sea would be if the mountain weren't there but its gravity were? The people who worry about such things, called geodetic scientists or
geodetic scientists, go about worrying about where the sea level would be if a mountain were there or it weren't there or anything, stuff like that. What happens in big dips in the water?
If that mountain wasn't there.
Yeah, where would the water be?
Density gradient will change.
Yeah.
Problem.
Yeah. It's a big worry, isn't it?
Decrease the water level height everywhere by digging down in the sea and putting it on the land.
Yeah.
Possibly.
Yeah.
What's the major difference between a geodetic scientist and a blue marble scientist?
No, I think they all worry about this sort of stuff, don't they?
Yeah. Too
much worry. Just be at peace with your globe, man. This is too much worry for anybody to worry about. Just know that it's measured already. They did the means.
Geodesists decided that we should indeed define sea level using the strength of gravity, so they went about creating an incredibly detailed model.
They should define sea level using the strength of gravity. These scientists.
I'm going to need a citation for that.
Well, it was actually measured, right? At least in the UK. So how it's defined, I don't know. I guess that's one of those definitional shift things. But, I mean, hey, they're good at that, aren't they?
The Earth's gravitational field, called creatively the Earth gravitational model. It's incorporated into modern GPS receivers, so they won't tell you you're 100 meters below sea level when you're in fact sitting on the beach in Sri Lanka, which has weak gravity. And the model has allowed geodesists themselves to correctly predict the average level of the ocean to within a meter everywhere on Earth, which is why we all...
They correctly predicted it. It was measured already. The means. But they predicted it, don't worry. They correctly predicted it.
So use it to define what sea level would be beneath mountains, if they weren't there, but their gravity were.
So look, did you know that? that
True.
when you have sea level, that'll go up a bit where mountains are. So when you're thinking about the elevation of the mountain, it's not the elevation from sea level, because the sea level will have gone up a bit already. So it's actually higher than you would imagine it to be because of the shift of the sea level upwards, I think. That's what he's saying. That's what it looks like there, isn't it? It's down here, but all the way up there. Remember, Jesse Kozlowski put this. This is on Jesse Kozlowski's channel, right? So he's one of these people that worries about, at least part-time, sort of hobbyist of this sort of stuff. So, well.
This episode of Minute Physics is supported by Audible.com, the leading provider of audiobooks.
Thank you very much, Jesse. Well done. So that's, now we know what sea level is with Jesse. We can go.
Wait, where was the conclusion in the video? I wanted to know how high Mount Everest was.
No, it didn't tell you that. It
Well,
just told
you
you
will
about how
never
they
know.
define sea level.
Ah,
This knowledge is not for you.
Yeah.
apparently not. This is occult knowledge, apparently.
It didn't have time to do that to do the video.
I think they measure it with angles now anyway, mountains. Well, you know, the Blue Marble site or something.
Yeah, angular size will do. John McIntyre's Mountain of Evidence. I don't even know who he was. Sea level and vertical datums, transforming heights.
Oops.
No, that's Jesse Kozlowski. Flat level lake measurements. Have a look at that one. Flat Earth proof, show us the measurements. He's obsessed about these flat Earth stuff. Reciprocal zenith angles. Perfectly flat level lake. There was one that said horizontal.
Oh, there it was, further down.
Was it?
Wasn't it? No.
Horizontal
Yeah, there you go.
plane made using a theodolite. So here we go, look.
Lights basically consist of a series of mutually perpendicular axes. The vertical axis, which passes through the center of the horizontal circle, the Trunnion axis, which passes through the center of the vertical circle, and the line of collimation, or line of sight, which passes along the center of the telescope through the center of the crosshairs on the diaphragm. Before it can be used to measure angles, the theodolite must be carefully centered and leveled so that its vertical axis passes vertically through the station, its horizontal circle lies in a horizontal plane, and its vertical circle lies in a vertical plane.
There you go.
Yeah.
Wasn't very
Mutually
good, so that's
perpendicular.
good. Yeah. Everyone's okay with that. So a horizontal plane. Now there was another one where he did a horizontal. Definitely possible though, right? Who was it that was the other day was talking about? It was Beddy, wasn't it? Water level establishes a horizontal plane, and now that one does a horizontal plane. Let's see this.
Oh,
one.
When you and the team are pitching a new product, Grammarly's tone suggests.
What's that look like? There we go. So he's on a lake. This is Jesse Kozlowski doing blue marble surveying using non-standard practices. He's definitely there. He's at the side of the lake. There's lake water there.
Hey, hello again. Here's a update to my blog with some data that I posted today. This is a little experiment I did at a lake, using the lake as a level to set some stakes. I'll go through and describe
use the lake as a level.
What I have here, and I'll leave a link to this blog so you can come and get this data. I'll leave the link in the description to this video. First of all, I'll show you. First of all, let me talk about this a minute. This is Union Lake in Millville, and I set some points on either side of the lake. And
so anybody else can do this. This is Jesse Kozlowski's method for well, flat level lake measurements, it's called.
I'll show you where that is. Set 2 stakes on the shore of the southwestern side and 2 stakes over on the northeastern side, like a boat ramp area. And you can clearly you have good visibility across here. And it turns out that this is about a half a mile.
Half a mile.
Across. And you're seeing also the vectors that I processed from a continually operating reference station here. I pulled that data off of the internet.
So that's a base station.
So I logged carrier phase,
one of the satellites, I should
GNSS
call it,
data, and also made numerous repetitions of theodolite observations using the wild T2 theodolite. So that kind of orients you to this this area, what I was doing there. There's not much to it, not too much to it. Just close that, save that.
So this is how easy
carrying on
it is.
Here through the blog, I'll describe what I did.
Go on.
I set 2 stakes to be level with one another.
Okay, everybody aware of this? You with what Jesse did?
Not really. I've heard this phraseology so many times now, and what does it mean? 2 stakes that are level with one another.
It just means they're at the same height.
That is what he means, yes, that they are at equal elevation, the tops of both stakes.
Yes, and I would also say you don't get a spirit level and do it. Like, I don't know what he's doing here. This isn't normal surveying practice. You don't see surveyors go into the side of lakes and banging sticks into the floor and then putting a spirit level on it. It looks like a plumber's spirit level. Doesn't it? Does everyone see that? Does it look like a plumber's spirit level? I'd say so.
And
maybe.
I measured what that height was above the water.
Like. Look. And then he measured.
Basically, I set a stake in the water. Put a stone here.
Put a stone
the
there.
water was very calm, and I was able to measure up.
So he put a stone and then measured to the top of the stick that he's banged in the water.
0.175 meters.
Like a professional.
So that when I went across to the other side.
Yeah.
Then it's on top of a stone.
Yeah. It's professional, right? Professional stick, and that measure there.
It's a good job. There was a perfect size stone there.
Yeah. Yeah, he found a stone just the right size.
I made sure that the stakes I set were the same.
Yeah, see.
And that's what I'm talking about here. All 4 stakes are set to be the same height above the water.
So the same height above the water, even though they're half a mile apart. And he's using the water in the lake as a reference. That's what he's using for level. Surface of the water for his sticks. And then he's putting these equipment over the top of it.
And here you're seeing what I did was I set the GNSS receiver on one of the stakes, and this is a 2 meter fixed height rod.
2 meters.
So it's 2 meters above
vertically.
the stake.
Dead vertical.
Here I have the target set over a stake, and I measured the height.
Vertical, obviously. See that? So that one's 2 meters, and this one's, yeah, something around there. Because he's obviously measuring that, right? He knows how to measure. You know how to make. Everybody knows how vertical measurements are made, right?
Yeah, I just haphazardly use a measuring tape, of course.
Does that look like it's
perpendicular
vertical? Does it?
I think he's got a hypotenuse there.
I think you might be correct there.
But I mean, like, he'll have adjusted with a stone at the bottom somewhere. You know,
yeah,
take a bit
plus
off.
or minus a few mil.
Yeah, he can convert it. He'll have a thing to convert it.
It was about 30 degrees, so you just had to work that out.
Every time I moved a target, that's the height I set it at. And
Look, that's the height he set it at.
That's what I did. So
it's not easy to do it, but that's what he did, right? It's not easy to get that same angle every time whenever you're doing it, rather than measuring vertical. Do you reckon that's because the stick is underneath it and he's had to put this on top of the stick? That's why it's at an angle. Do you reckon?
That every single time I put the target over any one of these 4 stakes, that's the height that I set it to.
That's the height. That
and
angle.
Here on this side, you're seeing again, I have the GPS receiver set next to me. It's 2 meters above the stake, and the theodolite is set to be at the same height as the target. So across the water,
this measuring the side of it.
Basically, looking at
in
a
America.
target that is set at the same height above the stake as the theodolite, and both stakes are set at the same height above the.
You know, like, spot on. You've used an auto level and all that. Whenever you measure a height of anything, you do like a backside, foresight type thing, don't you? You take a measurement reading from within the auto level with the crosshair. Apparently not. Apparently you should have put a ruler at the side of it and measured the height of the actual thing. But I mean, different methods for different people, right? This may be in America. Well, yeah. I mean, I don't know. I can't say. Maybe we're thinking this planar local surveying, and Jesse might be a geodetic sort of scientist that other guy was talking about, the warriors. Geodetic warriors.
I wonder if there's a mountain nearby as well.
Yeah. Yeah, you might be able to adjust it height-wise if there's a bit of a hill. There's obviously a mound because he's on the bank.
The water.
Might need to check gravity or something.
So then I'm showing you pictures. Whoops, I don't know how that happens.
Oh. Come on, Jesse. Look, he's got his umbrellas and everything. Do you see that?
Again, I'm showing you
didn't
that
even have that spot on.
A target was set to be precisely leveled over each stake, and the theodolite each time it was set up
looks new,
was also precisely leveled.
It keeps it clean. Huh?
And then here I'm showing you a picture.
Showing a picture over the water.
A pointing done here.
Can you see that? I mean, I know it's only it's a small picture, but it's only half a mile away, right? So I don't know if anybody knows anything, but how far would you reckon that would be? I mean, that looks nearly at the 2 meter mark, doesn't it? Didn't he say those ones were at 2 meters? Didn't he? He said those big ones are at 2 meters, didn't he? So I mean, that's handy. Look, that's well over what he needs. He's got some spare there. Good for you, Jesse. Yeah.
GNSS pole.
Yeah.
Or to the bottom of the GNSS receiver. So I made numerous repetitions of zenith angles and horizontal angles to both the top of the pole and also to the target next
horizontal
to the
angles.
And okay, so that's what I'm showing you here. Later in the day, the sun became a problem a little bit, so I got the old current umbrella out and
See, we need
cast some
one of them,
shade
spot on.
to minimize that. The sighting was still very good, and here's a side view just showing you that current umbrella casting a nice shadow.
Connor, he's doing some
on the instrument.
I thought he was expecting rain.
Product placement. You can just keep mentioning that. So other umbrellas are available for other people, right? You have to make that
2
aware.
meters high.
Yeah.
So basically, I'm just showing you a snapshot of the GNSS processing I did.
So he did some processing. Look at that.
This is the Rhinex data.
Look,
by the way, if you're interested in this topic, I did a video on GPS.
Looking at see, we'll go over these bits.
Or what should I say? Commonly known 8 inches times the miles squared. And
no way.
Basically, the drop across that half a mile would be less than 2 inches.
Less than 2 inches, but it looked like a load more. But I mean, I guess you can't really tell. We'll get off this because I mean that's theodolite. Who knows what he's doing with his theodolites? He's got some more stuff though. He's like Jesse. Google Street View picked up his survey points. This one horizontal. Sundial. He aligned his sundial with his thing.
What's the one on the left there, Bev? With the level, the plumber's level again.
Levels, seeking level. It's only a minute. Here we go.
When you and the team are pitching a new product, Grammarly's tone suggestions can offer a more personal.
There we go.
What makes a level level? Oh, here's a level. Set up level. Oh, here's another level.
Oh, it's got lots of them, hasn't he?
Set up level.
Set it up on top of the boxes.
You can hear the internal compensator on these automatic levels. Do you hear that?
Oh. Rattling his levels. Levels. Look at that. We are actually the home of levelology, so I can give him that. He's got quite a few levels though, hasn't he, at least?
But I mean, he's using a level there.
Yeah.
The plumber's level.
He levelled them up on top of the box, yeah.
2 foot, that one, I think.
Handheld sight level. Portable.
Oh.
Let me find this. Here we go. This.
Chasing that A and want to save time?
This is a good
Grammarly makes editing one click simpler.
All right, we've returned here to where we were last night. This is the point that I established last night to measure back to the Marriott building.
So remember last night we were going over the sound lead one, and he said about the Marriott, and in the book it said about his Marriott. He started looking across the Marriott first. So this is Jesse Kozlowski with an auto level.
With the T2 theodolite. There was a comment made on the channel, on my channel, about something to do with there must be a problem with the
I mean, look at that. Look how well he does. He must keep them touched up with the paint job and keep them polished and all of that. I mean, he takes really good care of his equipment, doesn't he?
Either the instrument
Really
or the
nice,
method,
that.
unclear. But that this bridge should not be below the horizontal crosshair.
Should not be below.
So what I'm going to do now is make a continuous video clip of, hold on a second. I want to just do one continuous video. So you can see what we're talking about. I'm going to say that this level is situated at 4.45 feet.
He's going to say that it's situated at 4.45 feet. See, they do have different methods, don't they? This is an auto level. And when we would normally do it, we would find a benchmark somewhere and sight back to that.
Yeah, you look through at the staff.
Yeah, to the measuring rod.
You don't measure, you don't
but
measure
he doesn't
that.
have a measuring rod. You know when B-Ball got his auto level and he didn't get a measuring rod? It may be because Jesse had this. You just need a little stick to measure how high it is. And you just say, I'm going to say it's 4.5 feet or whatever. And that's good enough. Is it a geodetic scientist or a geodetic worrier? I'll call them geodetic worriers. So,
above my point, which I do not know the elevation of yet.
So he doesn't know the elevation.
I still have a lot of
it.
notes to reduce from the data we've collected these past couple days.
Right, so he's measured it from the side and now he's measuring it from the back just to confirm. You can say around 4. I mean, is that 4? Is that 4'5", or is it one of those American measuring
4 foot
surveying 4.5 foot
4.3 foot or something?
Yeah,
4.5 foot
American metric feet. I don't know.
So you tell me. I'm seeing 440.
You tell him.
441 or 2 thereabouts. Close enough.
Is everybody? You want to help out with his surveying? Help Jesse out with the height of his auto level.
What did he say? He said 4 foot.
He said,
what?
"Help me out." Okay.
No, he's not. What's the measurement he said?
So you tell me. I'm seeing 440, 441 or 2 thereabouts. Close enough.
441 or 2, close enough. It's thereabouts. He's only put it on the floor underneath it, so I mean he's not referencing it to anything, so it's going to be vitally important though, no doubt. You need to know.
Alright, so
yeah, here we go. So
toss this over here for a second.
Yep, that's his measuring rod. Measuring stick.
So I'm going to use the auto level.
Someone says you need a measuring stick.
I've got it.
One of them, didn't he?
Yeah.
Yeah, you're going to need a measuring stick with that, mate. And he's gone,
no, I've got one of those. I'll get, yeah. Ruhif said we could just use 30-meter rulers. It's fair enough. Don't worry about it.
Level. I'm going to try to show you.
It's level.
The causeway.
It's level, but I mean, did he show us the 2-peg test? Do you reckon he did a 2-peg test? Do you reckon Jesse Kozlowski's or the geodetic warriors ever need to do a 2-peg test to establish that was actually level? Or, I don't suppose with that equipment you wouldn't need to. Didn't see a calibration certificate on it.
We cannot see the Marriott today because it's pretty hazy, as you're going to see.
Not too big a hump. It's just hazy.
But you could definitely see the huts.
Look.
This is not easy to do. The huts are below the horizontal crosshair. All right, let's swing the telescope to the left. Slightly to the left. We'll come back over here. Pause there. Oh. And some more. Oh.
It's hard work, this, isn't it?
Yeah, I used some glue on mine.
See, he hasn't really got a clue what he's doing. I mean, we do. I don't think there's anybody that does the on the level sort of stuff like we do. Sort of carved a niche out here for ourselves, right? You can see the problem he's got. So he's establishing a horizontal plane. Can definitely establish a horizontal plane with this tool.
And some more. Stop.
Who's he talking to? Has he got somebody there with him? Or is he talking to himself?
And some more.
Documenting this video format.
See, he's look at that.
Doing. A bit wobbly, isn't it? I mean,
yeah.
Okay, good.
Okay, good.
And that's just about where we are. We're looking
at the
very close by. In fact, I'll tilt it over, come over a little bit right there, and see what we got nearby.
See, look, there it is. Right. At this point, Jesse should be saying,
now we're gonna.
This is
I want to.
let's
just swing back out again.
Procedure.
Let me get on there. Hold on.
He's done no calibration checks. He's not done a 2-peg test. He's got no benchmarks anywhere, and he is using it. It seems like it's
and go.
For this. Go.
Keep going. Continue. Continue. Continue.
He's talking to himself.
Continue.
Oh, here we go.
Ho ho ho.
Oh,
catch up to you. All right,
catch
go.
up to you.
Ho ho ho.
He has got somebody there with him.
And continue.
It's a 2-man job.
Stop.
he thinks whoever he's talking to is in the camera.
Continue. Stop. Continue.
No, he's got somebody there with him. It's a 2-man job. I mean, you can't do that. You can't turn the auto level on and keep the camera on it at the same time.
And go.
Oh, here we go. Look. Whoa, wait. Oh,
now,
Jesse, that's your fault, Jesse.
Hold it, stop right there. Okay, now, we're looking close to where the Marriott is. Marriott's probably to the right a little bit. We can't see it in the haze. But we do see the huts are below the horizontal crosshair. We can compare the imagery that Soundly took last night, and you have good reference here. Wow! Oh, there's the Marriott. I thought I just saw it. There it is.
No,
it's there.
Really? No way.
Woo-hoo!
I can't see it.
Okay, now what I want to do is swing right. We're going to swing out, and you're going to watch the horizontal tangent plane established by this leveling instrument.
What?
Remains parallel to the horizon. So let's do that. Let's swing right.
The horizontal tangent plane stays parallel to the horizon. Okay.
Doesn't make any sense.
That sounds good. It's just you've got to say that the horizontal plane established by it is going to stay parallel. I wouldn't say it's the horizon, but it's up to Jesse, isn't it? The surface of the water.
Hold it. Let me catch up to you. All right. And go. Go. And pause. And go. Hold it. Let me catch up to you.
It's good footage, this, isn't it?
Okay, go. 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 Continue.
He could do with some better
I'm gonna
equipment.
just
He's gonna need to do that.
Fast forward. We'll go all the way over to here, maybe to where that thing is there. And over here, you're going to see trees or land sticking up above the lake.
Really?
I saw this earlier. All right, so let's swing back to the left.
That parallel.
And like I said, you'll notice that the horizon is flat. The horizontal tangent plane we've created
there's
here
no hump then?
is parallel to it.
Yeah, he's got the horizontal crosshairs. He's parallel to. He did say flat there. Don't worry about it, Blue. I'm pretty sure he didn't mean it when he said that. But want to hear it again?
Don't advise taking your auto level down the beach.
Yeah, don't do this normally. This isn't a usual thing for people to do. I mean, if you want to show people what, where the crosshair is in an auto level and how it works, do it properly. Don't haphazardly sort of put a phone over it. Look at it.
All right, so let's swing back to the left. And like I said, you'll notice that the horizon is flat. The horizontal tangent plane we've created here is parallel to it.
Uh-oh. I'm pretty sure he didn't mean to say that, Blue. The horizon is we'll leave the other bit, your trigger word out of it. But the horizon, it seems that Jesse Kozlowski says, is parallel to the horizontal plane established by the auto level.
Okay.
It's good.
Stop there. All right, so it's parallel there. Swing about.
It's parallel there.
Here's the causeway.
For there.
Here's where we are, just for visual. Let's come about midway between.
It's going to be parallel. Make sure.
And come to the left.
It's the same, isn't it?
Right about there, stop. And let's go some more. Good, just swing it over. Right about there.
Let's have a look at this now then.
All right, so you get the idea that the horizon is flat, and this horizontal tangent plane, it is tangent to the direction of the vertical here. It's perpendicular to it, okay?
Did he say it's tangent to the direction of the vertical? I mean, I'm not so sure that's the right idea of a tangent, is it? Are you sure this guy's a surveyor, Blue? Is he your mate? Have you ever checked this?
Now, the comment left on the channel, my channel, was something about that to check my level, there's something wrong with it, use a laser to check it or something. Well, who's to say that the laser's correct?
Yeah.
This should be a self-checking procedure. Now, what I'm going to do is we're going to drastically exaggerate out of...
It should be a self-checking procedure. He should have already done a 2-peg test to make sure it's okay. But, I mean, he's going to do some geodetic warriors
level.
Stuff.
We're going to tilt it up and make it look like it's way over top of the causeway. And what you're going to see when we start to rotate back toward the horizon, you're going to see that horizontal crosshair slice right into the horizon.
Really?
Okay, it's going to just dip right in. So if I'm tilted upwards in this direction, it's going to slice down in this direction. So let's take a look at that. So I'm going to get back on the causeway. Right there. I think the Marriott's gone again, but I think we caught a glimpse of it. It's very hazy today. Okay, here we go. I just want to...
Have we got some people in the chat saying the till's not working? It is. It's working exactly as it's meant to be doing. Unfortunately, if you're expecting the horizon to rise to eye level, or what you imagine, it doesn't. It never has, and it never will.
I'm going to try to make this in one continuous clip. All right, now, there we go. Oh, there it is. I do see it again. At least I see. Oh, yeah, there it is.
I can't see it.
Awesome. All right, so go ahead and punch that. That bubble is going to go out. Just start doing it a little bit so they get the idea. It's going to go out. Ho. Now, I want to try to film what that looks like when that thing's getting tilted upwards. All right, drive it up. We'll just put it right over top of the Marriott. Oh, look at that. Good. Oh, yeah, man. Look at the Earth's curvature. You know,
What?
If I'm out here with the wrong instrument or I'm using it incorrectly, you can get results that look like this. So, crazy, you know? So, that looks horrible. So, now, let's start going this way, and you're going to see the horizontal tangent is no longer horizontal or tangent. It's definitely inclined. There you go. Go. Let's fast forward here. Here, get over here a little bit. Right, go. Oh, wait, let me get on here. All right, so you can see we're getting closer and closer. Oh, stop right there. All right, we're definitely driving down toward the horizon. Fast forward a little bit. And wait. Definitely getting closer. You know, at some point we're going to intersect with the horizon.
You reckon?
Let's stop there for a second. And some more. Oh, we've entered that gazebo. Let's come out to the left of it. Okay, but you get the idea. If I kept going, eventually we're going to just intersect the horizon. So let's go back this way a little bit. You're gonna.
Is there anybody here that knows what they're talking about? Obviously not Jesse Kozlowski. It's floating, isn't it? So there's going to be a bit where it actually starts floating again. And I don't think it will. It'll only be when it picks it back up again. So, I mean, hey, that's enough of that bit for a little bit.
I can't see what's going on, Ben.
He was just sort of turning the thing. I mean, it was pretty bad. Oh, look, he's got one here promoting From Jesse YouTube channel 2 years ago. Jesse Kozlowski did that on his own channel. Isn't that strange? Shout out From Jesse. Another guy who was taking over, I think, when Jesse decided not to come back again. Earth radius measured by Larry Scott. So Jesse Kozlowski has put loads of stuff on his car. He's done all sorts of stuff. Look at all of this equipment. He's got a level, sun altitude angles, show us your measurements. He's talking to people. The shape of flat Kansas. Talks about it a lot. Radian Lake. Reported and animated. We might even need to get back at that. Walter Bislin's radius calculator. Presuppose no more. Earth radius measured. That was from here. Edward Hendry. That's the guy that wrote the book that I was talking about. So he's done a video to that. Where is the curve on Lake Pontchartrain?
When you get your next big idea, Grammarly's tone suggestions can help pitch it with confidence to get.
Alrighty, it is 2 weeks
since I was down in Louisiana working with Soundly at Little Tensas Bayou and Lake Pontchartrain. Zenith angle, 276, 06, 15. I'm going to go to M2, the red light.
He's measuring the height
Horizontal.
of the...
85.
It's good, isn't it? This sort of stuff.
Now I stole this little image
Just
from
blink tests and all sorts.
Soundly's video called Blink Test Marriott. You should take a look at it, and you can see the
Who else
minute
does
mark
blink tests?
where I took this from. Where Soundly has...
Right, we're going to have to go back to... let me get to this. I don't want to be wasting too much time. Wrong Jesse, dummy. What are you talking about? From Jesse's Jesse Gordon, Blue. We know who he is. Blue. Jesse Kozlowski promoted Jesse Gordon. No, he did it over on Jose's. We know that. Blue. I need to just swap this over. Because some of this stuff, talking of blink tests, does anybody know who's the blink test guy who does the most blink tests? Does anybody know what a blink test is?
I really don't know, I think.
A blink test is where they have two different pictures of different things and flick them from one to the other. And that's B-ball does that the most.
Does it prove anything?
No. No, they just show you two different pictures. No, usually from two different places. The water's on one of them. Oh, Wiggles is here. Right, can you guys see that? Swapped it over. This one's called B-ball's tangent to a straight line, and this is quite interesting, seeing as Jesse Kozlowski was talking about a tangent plane. This one might hopefully help you to understand where that tangent plane comes from, right? Where it actually is, what it is, what point it is, and welcome, Jose. Jose Tangent Man. It's a tangent here, tangent there, tangent. Well, this is what B-ball and I think it was Icon Science that said.
Hold on 1 second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
Yes, this is basic geometry. Your flat Earth geometry. Flat Earth.
Yeah, that's right, Wally. Wally's just said that Reds as well. Reds does them. Ruhif does them. Yeah, Reds. That's Reds Rhetoric and Ruhif and B-ball. Do you need? No, you've seen a true level bitch.
Bitch. I called you a flat earther. True level bitch. I called you a flat earther. True level bitch. I called you a flat earther. Yeah. True level bitch.
When you get to the end of this test and you have a result and you say level is horizontal and everyone says big whoop, that doesn't prove anything about the shape of the earth, will you then say yes it does?
No.
No. Okay, I'm going to bed. Right.
Okay, so
I'm going to bed.
That level is horizontal is good for you then, right?
I agree. I agree. Level's horizontal. All
Sweet.
Right,
true level bitch.
Perfect.
Wow.
Nice, mate. I came
Nice.
in just for that. You flipped it, man.
Yeah. True level bitch.
Right. Presume, right, that everyone in the room hasn't got a clue. Please describe a curve. It's very simple. Go.
Yep. So that's basically what I said before, that you could say that it's just a line, any line. It's a bit more complex when you try to define it rigorously, but you can think of it just as any line. Can also be a straight line. I would say that a straight line is a special kind of a curve.
Yeah.
Basically a curve with some additional properties.
So you can have a
Like-
curve being a straight line and a straight line being a curve, and you don't see that there's a problem with the law of non-contradiction there at all, do you?
Most ridiculous thing I ever heard.
It's not a...
Is that?
I was gonna say that's the most ridiculous thing I ever heard.
Well,
This is
this is
it's
sophistry.
a straight line, but that's how I describe a curved line, is by calling it a straight line.
Yeah.
Like, what the fuck?
Yeah, this is where we're at. This is the sophistry rife within this conversation when it comes down to a straight line. This is where we're at.
The contradiction. There is not a problem with law of non-contradiction because you're still stuck.
Here we go. Listen to that again. It does need listening
very
to.
simple.
Go. Describing a
So
curve.
that's basically what I said before, that you could say that it's just a line, any line. It's a bit more complex when you try to define it rigorously, but you can think of it just as any line. Can also be a straight line. I would say that a straight line is a special kind of a curve.
Yeah.
Basically a curve with some additional properties.
So you can have a
Like-
curve being a straight line and a straight line being a curve, and you don't see that there's a problem with the law of non-contradiction there at all, do you?
It's not a law of it's not a contradiction. There is not a problem with law of non-contradiction because you're still stuck with definitions that basically, well, you're still trying to stick your understanding of the word curve to what I'm saying that I define as the word curve. Well, the other way around. What I define the word curve to mean.
Think about looking through an auto level, right?
As for
And then you- and then
tangent
you-
having only one point in common, okay?
And then you tilt the
Here we
auto level down so the crosshairs are touching the horizon.
You tilt the auto level down so the crosshairs are touching the horizon. Can you do that again?
Excuse me.
This
That's
is
called tool abuse.
Yep. This is B-ball, or currently known as Earth is Life. This is what he says.
As for
And then you-
tangent having only one point in common, okay?
And then you tilt the auto level down so the crosshairs are touching the horizon. That's a tangent. That's a horizon.
You tilt. See, now, Jesse Kozlowski just said that before, but he didn't tilt it to make it a tangent. He just made it an air tangent. Whereas B-ball wants to tilt it to make it a tangent. Very strange. Tilt it to something that it's parallel to, so it touches the thing.
Or it's a horizontal plane intersecting with the horizon. That's your tangent.
Problem, like how B-ball's explaining it is, I've got a tape measure, and if I stretch that out, that tape measure is straight in one way, but if I let it curve the least amount, my measurement's off. So I need that thing as straight as possible in the strictest sense. So when you say something is straight but curved, it's just a problem for me.
Well, look at the picture I just posted in the chat. That's a straight road, right? But we're going over several hills.
That seems like a
that-
colloquial sense of a term straight.
Am I still not driving straight?
Well, I mean, it's still got curves in the road.
No, it doesn't have curves in the road. Hold on one second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
It has hills in it.
I'm driving straight. I'm not turning left or right.
So again, if you look three-dimensionally, then of course there are curves in like the vertical direction, right? But if you look at the geometry of the surface itself, So again, if you look,
listen to this. Listen to the words that this man uses. And remember, we are always talking about reality, 3D. Listen to this.
look three-dimensionally, then of course there are curves in like the vertical direction, right?
So if you look three-dimensionally, you will see that there are curves.
But if you look at the geometry of the surface itself, if you just
Hold on 1 second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
if you just restrict yourself to the two dimensions of the surface, to the left, right, and forwards, backwards, in this sense, it is straight, right?
So if you're looking at this three-dimensionally, it looks curves. But if you enter into two-dimensional thinking, well, science it out will tell you.
Doesn't turn left or right, and that's the point. Actually, if the hills have different shapes, then actually this road might not even turn out to be straight. It depends on the geometry of the surface, but yeah, I think that's the point here.
So can I ask you a question, guy? Hold on 1 second. Let me just say something. It's a tangent to a straight line which is on a curved surface.
And you're just looking at B-Ball's picture. The lines on the outside, are those lines curved or straight?
Well, of course, if you're in the center looking out, they look curved. Yes. So what's
Okay, good point. The lines on the outside of the road, yes, they are curved. Well done, Redmond.
But I'm still not driving to the left or the right, am I?
You're still going up and down, right?
But I'm not turning my wheel, am I?
Right. No, you're not. But you are going up and down, right?
Yeah, but yeah, I'm going up and down, but I'm still not deviating to the left or the right, so I'm still driving straight. No one ever says, "Hey, go down the road, and make sure you turn your wheel to the left because you're going up a hill."
Right. So from this, I reckon what you can say is that whenever you're referencing straight, you always have to reference it to B-Ball's car. Right? And if he doesn't need to turn his steering wheel, then that's the definition of straight as far as we're concerned with B-Ball. We're not actually talking about B-Ball's car. We're talking about actual straight and the geometric understanding, but B-Ball wants to bring in a road. That's okay. Two-dimensional thinking there, B-Ball. Can you not see the third dimension?
Yeah, but the point. We're not concerned with the third dimension though. We're just concerned with going straight.
We're concerned about straight. See, did you hear that? They're not concerned with the third dimension. 2D thinking. Blue Marble Scientists. It's Earth is Life is called. In reality.
We're concerned with going
in some
straight
contexts,
over the surface.
Yeah, what you're missing, Bev, is that geometry is a tool, and in some contexts it's simply useful to disregard the third dimension and only be concerned with the two dimensions.
No. Do you hear that? That's science it out, telling us to not use three-dimensional, whereas we live in three dimensions. The Euclidean three space we live in is what we are always talking about, not two dimensions. This is science it out, telling us to not think in three dimensions. Very strange, right? Very strange. It's never useful to confuse people about what straight
it's sometimes very useful.
is within geometry. Definitely not.
One other question to
Did you hear that? It's never useful to confuse people about what
it's sometimes very useful
is within geometry. He says it's sometimes very useful to confuse people. Do you want to hear that again? Just to make sure who's who's talking and who's being the sophist and what they're actually saying when they say this. Listen to him again.
And only be concerned with the 2 dimensions.
No,
and in such a context,
there's not. It's never useful to confuse people.
Oh
about
yeah,
what
it's
straight
sometimes very useful
is within geometry. So that's an open sophist telling you it's sometimes very useful to try and confuse people by saying 3D, 2D, and all of that. So what you're going to witness now is sophistry. Definitely not.
One other question to science it out, and I'll go back on mute. So, would you use a straight ruler or a bent ruler to do, whatever you need to do, measure something?
kind of depends on what do I want to measure. If I want to measure a circumference of a ball, then a straight ruler doesn't really make much sense, does it? But I wouldn't use a bent ruler either. I would use something like a tape measure and then curve it around the ball.
But is that straight or is it a curve?
Depends in what context we talking. If we're talking in the context of the geometry of the 3-dimensional space in which the ball is embedded, then of course it's curved. But then if I'm starting to consider the geometry of the sphere itself, it might be useful to call that straight. But it might be useful to call it straight, to define the word straight in this context slightly differently. Context is important.
I hope everybody's listening to this. It's pure sophistry. It might be useful for him to redefine straight in a different context. It's never useful to redefine straight in any different context.
This is not science, any kind of science anymore.
Mm-hmm.
It's just wizardry and telling fairy tales.
Sophistry. But, I mean, sophistry, low-grade sophistry, right? Treating people for a...
You know, like when you're trying to...
I'm good. Y'all good.
When you're trying to measure someone's body fat, and you use one of those measures around someone's belly, you got to make sure that little tape measure is straight around their belly. It can't
Don't
hurt.
measure body fat like that. That's a false equivalence anyway.
Yes, I've done it. I've done it hundreds of times, actually.
This is why people didn't want to get pinned down on the law of non-contradiction.
You see that? People's measured people's body fat hundreds of times by putting a tape measure around the belly.
Because you can just contradict yourself if you don't worry about that.
And he's talking about the BMI chart to see what your body fat content is. Right. So if you ever did it for real, you know where you're supposed to measure. It's not around your waist.
Yes, I know. I know exactly where to measure it.
Is it around your waist?
No, it's not. It's around the widest part of your abdomen.
Wrong.
Yes, I'm actually right about that. And it's around the navel, around the widest part of your abdomen. And for females, it's 3 different positions, isn't it?
No.
Yes,
it goes for the same. It goes for the same for everybody.
No,
you wouldn't measure that.
Are we talking about military standards or what?
Military standards. Are you in the military?
Yes, I am.
You still active in the military?
Yes, I am.
That's weird. But I'm gonna let y'all have it.
So he's in the military. He knows how to measure
So
BMI.
a straight line is sometimes a straight line, but when you want it to curve, it curves. Correct?
Yes, it's called context. I think he's been talking about it for a while.
It sounds like changing the law of non-contradiction to myself.
Nobody cares about your law.
Absolutely, Bev. Absolutely.
Not
Like
quite.
one thing being two things.
You guys are so one-dimensional. It's ridiculous.
Well, of course you wouldn't want to talk about the law of non-contradiction just so you can contradict yourself.
Who cares about the law of non-contradiction? Who cares about that?
Who cares about the law of non-contradiction? We've got straight lines being curves and
They-
curves
they
being
don't.
straight lines. I mean, yeah, why do you need that? It's blue marble science, man. Well, sorry, not blue marble science, the person, just the scientific method of the blue marble that we're employing here. I mean, you don't need the law of non-contradiction. Now, that's old shit. Aristotle did that. Get rid of it. Get some new stuff going.
The basis to all conversations, people. It should be.
Straight lines on a surface of a sphere. You can have straight lines on a surface of a sphere. Like what's
Okay, so if I'm talking apples, then you can respond to me in oranges?
why do you guys fight against that so much? Yes, you can have a straight line on a sphere. What's wrong with that?
So an apple could be an orange? An apple could be an orange?
What does that even have to do with the conversation, Montreal?
Because you're making a straight line a curved line. I want to make that absolute.
You can have a straight line on a sphere. Why is that such a bad thing?
Right? Can anybody else see that why's, like B-Ball says, why is it such a bad thing that you can't have a straight line on a curve, on a sphere? It's hard work, isn't it?
Because it is impossible. That's why.
Well, this is one of those ones. I consider this one of those prime time questions, right? This is just when you find the right question to ask somebody who says a certain thing. Sophistry, right, needs checking, and it gets checked with because if you make a claim, then you're open to what we call the elenchi, and the elenchi is questioning about that claim. Here we go. B-Ball.
I'd phrase it slightly differently. You can have a class of lines on a sphere
That's definitely semantics, isn't it? Where you're just phrasing something differently so you can get away with saying a straight line is a curved line.
Important. No, I'm not saying a straight line is a curved line. I'm only saying that sometimes you might want to call different things straight lines than in other contexts.
Well, it's pretty clear what a straight line is, right?
It's only that. Well, apparently it's not.
Well, it is to us, to those people that know what a straight line is. But you and B-Ball seem to want to just call curved lines straight lines if you want to.
Yeah, because see, the point of mathematics is basically exploring what common properties imply, what common, basically, I don't know how to even say it. But basically mathematics is about abstracting away irrelevant details. So it turns out that straight lines, as you know them, and great circles on a sphere have enough properties in common that it's useful to use a single word to describe both of them in the same way.
Would that be why you can't have a tangent then?
What do you mean?
Well, you obviously can't have a tangent to a straight line, can you? I mean, that would fucking be ridiculous, wouldn't it?
You can. It's a straight line.
What, you can have
that straight line is tangent to itself.
No, you can't have a tangent. Did you hear that?
Yes, and he said before one thing when he was very, very wrong. He said that in mathematics you can abstract not important things, while it is quite opposite, because abstraction to create definition is abstracting substantial thing from the thing you are going to define. So this abstraction has to abstract substance from this. So this is, in case of line, it is being straight or being not straight. So this is substantial for a line, because this is like a substantial difference, which makes species. So he said just quite opposite. So maybe he didn't notice that he's talking nonsense. But
I think he did. This is sophistry.
Maybe if he did it intentionally, it means that he is just Lying? Oh, just wrong. Just wrong.
Yeah, I think they've got themselves into an argument, which quite a lot of these people have. Right? They want to have a straight line on a sphere. But like I said, is that why you can't have a tangent then? And he says, well, that tangent can be tangent to itself. Which is ridiculous. You can't have a straight line being tangent to itself because it touches at one point and one point only, not the whole thing. So that's ridiculous.
Yes, and part is not a whole, so
yeah,
it doesn't make any sense anyway.
Yeah, so sophistry, but this is geometric sophistry that may be useful to somebody if you're geometrically ignorant, right? But if you're not, then this is going to be easily exposed as obvious sophistry.
Yes, but he said that it may be useful. And he said that to cheat people. And he said in regard of geometry. So in geometry, sometimes you want to cheat.
To cheat people. Yeah. Obviously, in this game, the Blue Marble Sophists are definitely going to want to cheat people. And this is one of the ways they do it. This is exactly it. I mean, that would fucking be ridiculous, wouldn't it?
You can't. It's a straight line.
What you can have?
That straight line is tangent to itself.
No, you can't have a tangent to a straight line.
Who says? Who's trying to make it? Who's trying to make a tangent to a straight line?
You guys.
He just said he is. Do you know what a tangent is? First of all.
Yes, I know. Yes, I know what a tangent is.
Go ahead.
Is a tangent a straight line?
Yes, tangent is a straight line to a sphere.
Okay, so if you've got a straight line
which touches the sphere at one point.
Yeah, but
what about your other
part of the sphere is it touching? A curved line, or?
Mm-hmm.
Oh, right. So you do have curved lines on a sphere then.
A straight line on a sphere, yes.
No, so you can't have a tangent to a straight line.
Yeah, that's good. Yeah.
Think about it, B-Ball. Think about it real hard.
And there is a useful definition of a tangent.
So B-Ball's stuck now. He's sat there in aporia. He wants a great circle to be a straight line on a sphere. But then he's got a tangent and he wants to have a tangent to the sphere. But he's now developed the situation where he has to have a tangent, which is a straight line or plane, that is tangent to a straight line that he's developed onto his sphere. He's redefined a circle to a straight line, and now he's forced into the position of having a tangent to a straight line. By his own definition, he's the one that's defined it this way.
Yes, but it is still impossible because it means that there are no tangent lines on a sphere. You cannot have tangent on a sphere.
According to their definitions, right? The moment they make the great circle a straight line, then they have to do away with tangents. It becomes a two-dimensional surface when everybody knows 2D is a plane. And you can't have a tangent to a plane. It's not possible. So they've developed themselves a really awkward definitional argument through geometry. It's a massive failing of the Blue Marble scientific model.
Where basically a tangent to
he's helping him out now.
Something, to a figure or to a surface.
Yeah. Which is that curved surface at one point and one point only.
Okay, any surface actually. A tangent to a surface at point A would be defined the way this way basically. You take the point A, you take another point B on the surface. You put a line through the points A and B, and then basically a tangent will be the line through points A and B when B tends to the point A. Basically, you take points closer and closer to A, and the line through A and B is becomes closer and closer to the
And
tangent.
what is B? What is B?
So he's... Did you get that? He's got like a chord. And he said a tangent is when you bring the chord line closer together. And when one gets closer to the other. Well, no, a tangent touches at 1 point, 1 point only. If you've got 2 points, you've got a line, and you're not going to get a tangent, unfortunately.
And chord is inside a circle or sphere, so and it has to be outside to be a tangent.
Complete sophistry, right? But
yeah, I think that he's already confused.
Yeah.
So
B.
Well, that's
Any point at
2
all.
points, really. You can't. A tangent is only touches at 1 point, right? And 1 point only. Or have you got a new definition for tangent now?
Okay, let me put it this way.
Can I just check that you're trying to justify now having a tangent to a straight line, aren't you?
Of course, you can have a tangent to a straight line, and it is the line itself. But okay, let me put it this way.
Again, there's another, and this is B-ball coming in here. One of the classic lines. A tangent to a straight line, aren't you?
Of course, you can have a tangent to a straight line, and it is the line itself. But okay, let me put it this way.
Hold on 1 second. Let me just say something. It's a tangent to a straight line, which is on a curved surface.
Oh, are you having a tangent to a straight line as well, B-ball?
It's on a curved surface.
Yes. Why is it so hard for you guys to understand?
Why is it so hard for you guys to understand? It's a tangent to a straight line. It's just on a curved surface that you want to consider as a two-dimensional surface. They've messed themselves up here. I'm sorry about this. For anybody here that has a globe, right, please don't try and follow these guys. You'll mess your head up. You best just going home and saying, I'm really happy with my globe.
Do you remember when he denied saying that?
Yeah. Over at Jose's.
That was even.
I never said
that.
that.
Was even better.
So here we go again.
If only you realized what you just said, man.
Tangent to a straight line confirmed by B-ball, right?
Surface. We can have a straight line on a curved surface.
And you can
So
you can't have a tangent
now. We
to
have a tangent.
You can't have a tangent to a straight line, can you, B-ball?
It's really difficult for you guys to understand. You guys have been trying to figure this out for how long? 2, 3 years now?
Give me a picture. Make me understand.
Reject all of physics and all of geometry. You guys are trying to make your own geometry.
See, B-ball thinks that we are rejecting all physics and geometry because we're trying to make our own by sticking to the fundamental laws of geometry, by saying that a tangent only touches a curve at 1 point and 1 point only. That's it.
Yes, we are fundamentalists. Apparently.
Because we're not going along with their ridiculous tangent to a straight line. Tangent
we are
to
not
itself.
modern geometers.
This is B-ball. He's in the military, he says. In the US military.
You got a straight line on a curved surface that you call a straight line, but then you got a tangent to it, which you also call a straight line. That's a tangent to a straight line.
That's 3 objects right there. Yeah, not to mention 3 objects.
Think about looking through an auto level, right?
As for tangent having only one point in common, okay?
And then you tilt the auto level down so the crosshairs are touching the horizon. That's a tangent.
He's tilting it again.
That's a horizontal plane intersecting with the horizon. That's your tangent.
Crosshairs aren't touching the horizon.
So he's on about the horizontal plane touching the horizon, which is parallel to the plane of the horizon, and he thinks that's a tangent. Anybody, let us know how B-Ball managed to be able to make a horizontal touching the horizon. Let us know how you do that. So in fact, send them to B-Ball. Send them to Blue Marble or Nathan Oakley, one or the other.
Horizon, they're just within the optics.
We're kind of.
You'd have to angle them down in order so the crosshairs will be touching the horizon.
We're kind of going off on a tangent actually right now, but
yeah.
But what I was meaning to say, okay, so you guys are saying that the tangent can only have one point in common with the curve or surface it is tangent to, right?
Yeah, that's a tangent.
Okay. You know what a sinusoid is, right?
It's curve. It's called the tangent point, right?
Okay. Just a moment.
Yep.
Is a sinusoid a good curve for you?
Go on. Draw it for us, please.
Yeah, you know. Basically, if you just take a look at the picture that you posted actually a while ago, this level but not flat, it's basically a sinusoid, right?
That one, are you going along with that? Do you like that for a level? That's Anik, that. A wavy surface, right?
Okay,
Undulated.
yeah, but I don't care about what... I don't care. I only want to...
Just for anybody else listening, you're talking about an undulating wavy surface.
Yeah, you can call it that. I'm actually more interested in it as a curve, as a single curve, but it can also be a surface. I don't really care.
Well, it's not a single curve because it curves up and down, right?
Kind of like a hump.
Okay, I think we have another terminology disagreement here, because to me the line at the wavy line is a single curve.
So again, we're talking about a wavy line, and if anybody wants to correct me, he thinks it's one curve, whereas I would say there's a concave and a convex curve there. So there is a transference of the curve from negative to positive
in different directions.
Mm-hmm.
So.
But he wants to call it one curve again. Maybe a mathematical difference. I mean, this guy could be the mathematical genius that he seems to be for the Blue Marble scientist. But I'm not too sure. I'd say one of them's a negative curve and one of them's a positive curve.
Yeah, so we're using the word curve in different meanings, because to me curve is basically equivalent to a line.
Yeah,
it's because they think the surface of the Earth is a straight line. That's why.
But it doesn't matter. Okay, let's say.
As B-Ball just said that. Did you hear that? He said they think the surface of the Earth is a straight line, but didn't he just say he wanted the surface of a sphere to be a straight line?
He wanted it before, yes.
Yeah. So why is he saying that we want it? Has he lost his mind? Has he completely forgot about what he just said? Is he delusional? Has he been drinking? He shouldn't be doing. He's a military guy. Seems to be contradicting himself. That can't be safe. You don't want that in the military, do you?
Say that's a surface, okay? Can you have a tangent to this surface?
Yeah.
Okay, and how many points will that have in common with this surface?
Each of the curves that it touches, if they're all uniformly. Wave height, what do you call them? Frequency, or what would you call that? If they're all the same anyway, all the same height? Yeah, elevation? What would you call it? If you were to have a straight line, then they would all be the same height, then every one of those upward curves would touch it, yeah?
For example, yeah.
But those
So it would have
those
multiple
upward
points in
curves
common.
that those circles would relate to, the tangents that those circles would relate to, are joined by an opposite curve, aren't they? In order that they can join up to each other.
To me, that's still a single shape, and it's a single shape
not
which
to me,
have multiple points in common with the tangent to it.
There. Different curves.
Yeah, so that's a bit of a weird terminology that you're using there.
No, I think that's you trying to play with semantics, but so we
Not
understand that it only touches that curve at one point, right? It can't touch another point of the same circle, can it?
So hey, Bev, am I creating?
See, this goes along with the twin tangent conundrum that F.E. Dogma set them, right? You can't have more than one tangent to a circle. We're trying to get that across to them. We've been doing it for a bit, but I mean, F.E. Dogma definitely did his after this point, or he might have already done it beforehand. I don't know. I can't remember the timelines of all of this stuff. I know this is quite old.
Creating a tangent to a straight line in this picture.
I don't know. Where's your circle or your curve?
If I were to tilt the auto level down so the crosshairs are touching the water, would that be a tangent? And would that horizontal plane be a tangent to a straight line? Do you guys think the water is a straight line?
I was looking at that. What's up with your vertical? Is that something in the picture or my TV or something? Or does that vertical look like it's got a slant on it?
It's probably just the way I cropped the image.
Well, but it's... No, you can't crop that to make that vertical line.
No, but if you put a phone, put a phone to the lens slightly off center, then you will get an effect like that.
Well, I don't know. It's just the lines, right? The lines are definitely showing it up as being a slanted.
Well, is the horizontal line is it parallel to the surface of the water?
All horizontals are parallel.
You see
to the
that
plane
horizontal
of the horizon.
line going? Okay, do you see the horizontal
Where would
line?
you say the plane of the horizon would be in there?
Is it parallel to the water?
I don't know.
Well, I mean, you can look at it and see.
Well, yeah, look, it looks like it could be. Yeah. Have you measured it? What did you measure it at?
I didn't measure it at all.
Oh, okay.
Looks like it though.
Okay, brilliant.
But do you see what
looks great?
Am I creating a tangent?
You do realize that those crosshairs are within an inch of your eye, right?
Yeah, but that horizontal extends forever, pretty much.
Which horizontal?
The crosshair, the horizontal line in the where the crosshairs are.
Mm-hmm. Straight line.
Yes, that straight line. Where the crosshairs meet, that little plus sign.
Yes,
that extends out forever.
No,
right?
It's in your eye line, right? It's it's inches away from your eye.
Yeah, it's in the tool. Yeah, but it extends out.
No, it doesn't. It's within the tool.
So
you just use that as a frame of reference. See, I know he's only just got an auto level and all of that, right? But as you're looking through the eyepiece, there is a little tiny piece of plastic with these crosshairs on it that's by the lens where you're looking through, right? Now, that line there doesn't extend out. You could do damage with that if it did extend out beyond the auto level, but it doesn't. It stays in the crosshairs, and you use the image that comes to your eye to measure the thing, right? It doesn't shoot out. And there's a working range. We are going to go over this. We have gone over this quite a few times, and we can do it multiple times again. Come April time, we'll be getting on it. Reference when you're measuring.
Yeah, exactly. So if I wanted to build a wall that was horizontal to those crosshairs, I could do that, right? And I could extend that wall out.
You wouldn't
forever.
use it for building walls straight.
But I could though, right? I could use it to build a wall.
I doubt
it. Pretty level, right?
He thinks he could use an auto level to build a wall. Level. I mean, he's only just got an auto level for himself, I think, and he's gone to the beach to do this.
Don't you think?
I mean, like, for strange things to do. I mean, like, if you're thinking of doing a GoFundMe or whatever, then yeah, I mean, I'd go for it. I don't think it'd be useful. I mean, how good of a bricky have you done? Have you ever done any brickying?
Well, I mean, isn't that kind of like what the Force the Line guys were trying to do?
I don't know.
Yeah, I think that's what they were trying to do.
What? Build a
wall or something
with an auto level.
Very
using it
with whatever the hell they were trying to use.
It definitely wasn't. I had a word with Del. He definitely wasn't using the horizontal. He got upset when I said he should use a water level, but I mean, so yeah, no, I don't know. He definitely wasn't using an auto level.
Yeah, but they were trying to use something.
I don't know. They were doing brickying, like you say, building a wall. Are you?
I'm sure they were going to.
Is that your next one? Your next project?
No, I'm sure they were going to use something a hell of a lot more accurate because it costs so much
for building walls.
Yeah.
No, he just used spot on. I mean, he's not. I don't think he's here, is he? No, it's a shame he's not here. Yeah, he'd show you about brickying. He doesn't use auto levels for that. He would probably for marking the corner points and stuff, but for building the wall, he'd just use his bubble level.
Yeah, but whatever they were trying to do was going to be a hell of a lot more expensive than they could afford.
Who?
All the people that were involved in the Force the Line thing fell through, and the guy ran off with the money.
What was that they were doing? I don't know. What was it that they were meant to be doing?
They were trying to build some kind of wall, or I don't know what the hell they were doing, and then the guy ran off with the money.
I said to Del, I said you do it for a lot cheaper, £100, 400 meters. Get yourself a water level. He wasn't keen.
That makes sense, man. Good on you, Bev.
Branch, my man.
Oh, this is Branch. Branch came in to save them all. Nobody needs to hear Branch.
Yeah, you're right.
Oh, it's a shame, Branch. Of course he did.
Hannah, come on.
This is... and just go.
It's fine. Okay. I mean, everybody can have an invite to come over there.
Bev,
but
if that's the case, Bev, I'll just shush.
Thank you. Get rid of Branch. Anybody else? Nobody needs to hear that. Talk before Branch just starts talking again. Otherwise, we'll just have to go. Do you want to sort out this tangent to a straight line? Science it out. I mean, I have had somebody say a tangent to a horizontal, which I thought was pretty stupid at the time. But I mean, it seems like it's what's needed, right?
Basically, the thing is how you define tangent, and you can define it in a general way and in such a way that it also makes sense in reference to a plane or a straight line, and it's no problem. It's just a different definition.
Did you hear that? I don't know whether I heard that at the time or whether he was still talking. Let me hear that again. Stupid at the time, but I mean, it seems like it's what's needed, right?
Basically, the thing is how you define tangent, and you can define it in a general way and in such a way that it also makes sense in reference to a plane or a straight line, and it's no problem. It's just a different definition. Sometimes there are different definitions that are equivalent for some some domain, let's say, and that are not equivalent for something outside this domain, but turn out to be useful. Anyway.
See, B-ball even wrote it. Tangent line to a curve, tangent plane to a sphere. You know, me to get it. Copy image. I'll put it back in again. Like, even B-ball did that. There you go.
Yeah, and for example, in this second example, where you have a tangent line to a curve, well, if you kind of stretch this line, extend this line a bit to the left, it would intersect the curve. So you have 2 common points.
We was talking about when B-ball before was talking about a straight line on a sphere, right? So, and I said you can't. That's why you can't have a tangent in spherical geometry, isn't it? And you said yes, you can.
Actually, that's no problem.
You can have a tangent to a 2-dimensional surface.
Yeah, why not?
Well, because the tangent plane is the 2-dimensional surface.
Yeah, and the tangent to it is the same surface. It's the same plane. That's it.
It's the same plane.
Yeah.
Well, it's not a tangent then, is it?
Well, not a tangent in the sense
Isn't it more
that
like
you would
parallel?
think of it.
Wouldn't it be more like a parallel plane?
Well, also, but yeah, I don't see a problem with calling it a tangent as well.
Parallel, right?
It has many properties in common with tangents.
It's many properties common with tangents.
No single one.
None. Not a fucking thing. It's a plane. But how can it be a tangent to itself? How can a plane be tangent to itself? It's crazy. You've got sophistry with this. Come on.
No, not really.
Well, I don't know about. I mean, you obviously you've got a tangent to a straight line. Now, what is everybody else here meant to think about that? How can they take that away? How can they look at that, what they're saying there, tangent to a sphere, and then say, no, the sphere's 2D as well as the tangent plane. So you can just have 2 straight lines next to each other, and we'll call that tangent. I say that's ridiculous, right? But I'm guessing you say that's flat Earth, right?
I'm not sure where you took all this from, because I kind of lost you somewhere there.
Well, you say you can have a tangent to a straight line.
Yeah, you can. No problem.
Well, I say that's ridiculous. You can't.
Okay, as you wish.
But how's anybody else here that's meant to be listening to you meant to take that away when they know a tangent, like B-ball's done there in that thing, is a tangent to a circle or a sphere? Like it shows.
At least one person here seemed to agree with me, because they wrote that a tangent to a line is that same line a while ago.
Ooh, wow. Who was that?
Yeah, a tangent to a straight line is the line itself. I have a name now.
B-ball? No. Wouldn't it be B-ball?
No. The nickname is I have a name now.
Oh, I have a name now. Nice. So that's another one that has 2 straight lines. There you go. That's how you confirm it, right? Because somebody else in the chat said, yeah, a tangent to a straight line is the line itself. So he's going to go along with that. Somebody else has confirmed it in the chat for him. Then
hang on. Stop. Wait.
Come
on. Who in the chat said that?
He said somebody who had a name of I have a name now. So obviously a big name.
So a nobody.
Well, it could be one of his other stock accounts, or it could be one of the It could be a professor of mathematics from like Stansted, or like some really big. Could be Cambridge. Could be a professor of mathematics from Cambridge University, and he doesn't want anyone to know. So he could be saying that. Could be like, I have a name now. I'll just go and help him out there because he obviously needs some help. I don't know. It could either be a nobody or a mathematical genius that's just telling us this new modern day mathematics. I mean, are you a blue marble mathematician? Do you have the ability to just make up new definitions for geometric terms that have been well established for thousands of years?
No, see, I like the well-established definitions.
Oh, no.
They work. In reality, they work.
Yeah, these guys are into sophistry and redefining things. They've played a lot with this sort of stuff. They've thought about it a lot. This is where we're at. Do you want to hear him a bit more? It's next to each other and you call them...
But in what way next to each other? They are not next to each other.
On the same straight line, right?
Yeah, they are not next to each other. They are the same line.
So a one straight line can be tangent to itself.
Yeah, it can. It is.
It is. So you said that.
Yep.
A tangent.
Well, depends. Basically, depends.
The line itself. Wow.
So that is Let me see how it. Tangent to a curve. Let me see how you.
He's literally Googling it now. A tangent to a curve. After just making all of that stuff up, he's now Googling it. What do you reckon it's going to say to him?
I'll let people define it. Oh yeah, so the definition I told you earlier is appears to be by Leibniz. He defined it as the line through a pair of infinitely close points on the curve. So basically, you would use the notion of a limit to have those 2 points, and then basically tending in a limit to a single point and the line. The limit of the line through these 2 points would be the tangent, and the tangent defined this way to a line is the line itself, because basically whenever you take any 2 points on a line, then the line through these 2 points will be this line, of course, according to the axioms of the Euclidean geometry.
So he's redefined what a tangent is and used 2 points, and now he's saying through that sophistry that he can redefine Euclidean geometry to make a tangent to itself. Using that definition that he just made up. Very good. That's using the old school shit. Oh, that's what he's trying to tell you, Rob. I mean, somebody else redefined it differently, so he's using that.
And then if you go to a limit, when you take the points closer and closer together, well, the line doesn't change. It's still through these 2 points. It's still the same line. So in the limit, it is still the same line. And this way, the tangent to a line is the same line. So that would be according to the definition by Leibniz.
He literally just said that, right? That's mathematical geometric sophistry through definition. Suppose that's the best way to do it, right? Through the identity of the subject. You just try and use your sophistry to redefine things, because obviously you can't do sophistry with the logic in geometry. You've got to hit it at the before stage with the definition. Just confuse people, I think. Utterly ridiculous. I think it's disgusting. So.
No, it makes a lot of sense.
It doesn't make any sense to have a straight line being a tangent to itself.
Is Sean Hawkins joining also?
Mind you, it would support Jose. I mean, Jose was tangent, man, wasn't he? So all straight lines are tangents. So anytime he's pointing anywhere. Is that why you're saying this?
I don't know what you're referring to right now.
You don't know. Jose said, see that table over there? That's a tangent. See that piece of weed? He said that's a tangent. See the squeaky globe? That's a tangent. His clock that he got from WS? That's a tangent. He had everything as a tangent. Well, if you have a straight line being at a tangent to itself, then that would support Jose. So you've got, what's that guy called? And, that dude that has a name. And you and Jose. Oh, tangents to a straight line. I mean, that'd be great. Absolutely ridiculous, but...
Basically, ask any mathematician, and I'm pretty sure that they will also agree with me.
There you go. That is Globe Blue Marble Sophistry 101. Just ask any mathematician, and I'm sure that they'll agree with me. I like it. Try it next time. I bet it works. Well, are you a mathematician?
Not quite. By education, I'm a physicist.
A physicist? Nice.
But only by education.
Okay, so only by education?
Yep, I basically went into a career in programming instead of in physics. So, yeah, I do have some education in physics, but I'm a software developer as a job.
Okay, so what mathematics did you do? What geometry?
Lots of it, and the most I'm not sure what adjective to use here. Let's say the most advanced branch of geometry that I had contact with was differential geometry, and it's pretty fascinating.
Okay, what about the basic geometry, the foundations?
Yeah, you can. Yeah, you kind of have to know basic geometry in order to go higher.
Okay, and does the basic tangent that you have when you start off, does that change at these higher levels, or?
Well, in differential geometry, you have a notion of a tangent space even to a manifold, and it's a bit different.
A notion?
Yeah.
Okay. But in the actual geometry, you have a tangent, right? And it can be applied in Newtonian physics, right?
In various contexts. I mean, yeah, you basically define it. Now, that's the problem. If you go into more advanced territory, you kind of have this idea of how a notion generalizes to various cases. So I can't say I remember what was the precise, most basic definition of a tangent line. That's why I basically am referring to various different definitions, like the one by Leibniz I mentioned before.
See, when I think of geometry and physics and all of that, I think of Newton, obviously, most people would do. And the laws of motion and all of that are based upon Euclidean geometry. So therefore, a tangent, being a tangent as described within Euclidean geometry, follows through into Newtonian physics and mechanics and all sort of engineering and everything, really. It doesn't change ever. So I don't really know what he's talking about. Seems like pure sophistry to me. And this is what we had a bit ago, and he seems to have disappeared, this guy. He's left it to other sophists. We have other people like Darren and Blue Marble trying to support the case at the minute. Wally's, I think, one of the top ones that have left. But, I mean, that's it. You've got this guy trying to do sophistry with mathematics. You've got people bending horizontals. I mean, where are we? What are we doing? I mean, this is one of the ones. I mean, it's a bit ago that when we did this, but how much sophistry do you want people to have when in a discussion? Can you imagine trying to talk to somebody that's doing this about straight lines, tangents, basic geometry, basic physics as well? It's a software developer now. Right, but in physics though, when you're doing your vectors and everything within physics, you use Euclidean geometry, and a tangent in that form would be used and applied as the straight line coming from the circle, right?
Well, depends on the context, really.
I'm talking about Newtonian physics.
Yeah, but in what basically in what precise application of Newtonian physics?
Rotational forces for bands and pulleys.
Yeah, sure. Then you have okay. I can tell you one thing. So, for example, when you have an arbitrary motion, right? You have a particle that is in motion, and it's an arbitrary motion. It doesn't have to be straight line. It doesn't have to be uniform. It can be accelerated. It can be along a curve, whatever. Okay.
But it would be defined whatever motion that is, right?
Yeah, it will be defined somehow, whatever, in some way. Basically, let's say you have a particle in motion. Then, if you want to define this particle's velocity, then the velocity at any point of this motion would be along a tangent to the path of the motion, right?
Is Sean Hawkins joining also?
Basically, for example, if you have a particle moving...
He's just described a tangent.
Yeah, it's like, for example, centrifugal force. If we have centrifugal force, so this vector is like tangent to a circle.
Yeah, a tangent in the old Euclidean sense of a tangent, not a tangent to a straight line, which is ridiculous. Again, he's trying to explain something by going over the very thing that we're trying to talk to him about that he didn't have before. Diletheism. It gets really hard talking to people that have both things. He's just redefined his context so he can have whatever he wants to have.
Along a circle, then the velocity of this particle is tangent to the circle, for example, right?
Right, okay, so the circle would be the curved surface and the tangent would be a straight line. Yeah?
For example, let's say.
That's
but the point is,
that's exactly what I was talking about, Newtonian physics, right?
Okay, but my point is, if we say that it's true always, that velocity is always tangent to the path of the motion, then if we want to be able to apply this as a general rule to a motion along a straight line, then we have no choice but to accept that the tangent to a straight line is that straight line itself, because velocity...
You're right. Did you hear that? If we say that it's always tangent, then we can say if the motion's a straight line, then it's a tangent, because he's just redefined it as a tangent. Disgusting. But hey, this is what they're left with. I guess this is why science out isn't around anymore.
It will be along this straight line. And that's the point.
No, that's not.
That's the point. Then we can make a general statement that the velocity of a particle is always along a line tangent to its path. And we don't have to make a special case exception for a straight line, because then the tangent is the straight line. If you want to exclude the straight line from having a tangent, then you suddenly have to make a special case for this, because then you can't say that the velocity is always tangent to the path of motion. Because if you define the tangent this way, then when the motion is along a straight line, you don't have a tangent by your definition. So the statement doesn't apply, and you have suddenly a special case. But if you define a tangent to a straight line being that same straight line, you can make this as a general statement, then velocity is always along a tangent to the path of motion.
Right. Is everyone aware of that? He wants to redefine a tangent to be to a straight line because he redefines the path of a vector as always being tangent to the path of the motion or whatever.
And what is generally benefit from doing that? In physics, for example, or geometry? Because I still cannot see any benefit from that.
B-balls put him in the shit, and he's got to get himself out of it. It's like a game they play, I think, where they throw each other under the bus and then say, "Go on, you sort that one out." B-ball's no good at doing it. B-ball left, right? B-ball had the tangent to a straight line. Science It Out also then had to follow and help him out, and now Science It Out's been left on his own to sophisticatedly discuss how a tangent can be tangent to itself, making every straight line a tangent. That'll come in handy at some point, won't it? Because you could then just call any horizontal that you ever make a tangent. Since like Blue Marble and Rumpus the other day, and FE Dogma, where they had multiple tangents on the same horizontal, I'm guessing that's what they're doing. They're ready to make every point a tangent, and it can be anywhere. This is the build up to it. This is Flat Earth Society 101. How do you do it? How would you make every point a tangent point?
And that's what's beautiful in math. You basically define the notions in a way that is the most general.
You just made that up.
No.
Yeah, you did. That's what's beautiful about maths. You can just define things however you want, he says. I'm going to listen to him again.
And he is wrong.
Yeah, absolutely. Not. But Blue Marble science, this new modern day science, mathematics, is you can literally, they've took all of the Blue Marble scientific method and moved it over into mathematics and geometry. These guys can't be wrong whenever they say anything. This is what they do.
What's beautiful in math, you basically define the notions in a way that is the most general.
You just made that up.
No.
Yeah, you did. Tangent to a straight line. Fucking ridiculous. Load of bullshit. Nobody understood what you said, and I hope they didn't anyway, because it didn't make any sense.
Ask any mathematician or physicist. Well, I bet you that they will understand.
Are you a mathematician?
Only in the only in the sense in which I had to study mathematics in order to understand physics. So I'm not quite a mathematician, but I do know quite a bit of maths because I had to know it in order to study physics.
Well, like when I did surveying, I had to study geometry, so I knew the principles of the surveying methods that I did. That's actual geometry, right? So I learned the foundations of geometry through when I did my training. Just like you did with the mathematics when you did physics that you're now not doing anyway. Mm. Right? So when you keep saying, go and ask a mathematician, but you're not a mathematician, is there any mathematicians here?
Okay, then ask someone who will.
So you're speaking for mathematicians, but then saying that we need to go and talk to mathematicians in your form of your argument.
If you don't believe me, ask someone that is an actual mathematician.
Dude, I will, but until I do that, right? Can you stop doing that?
Doing what?
Speaking for people and then asking us to go and talk to the people that you were speaking for.
I'm not speaking for them. I'm not speaking for them. I'm not telling you that they, I don't know. No, okay. I don't feel like I'm speaking.
Is it an appeal to authority that he just did?
Yes.
Yeah. So how can he be speaking for the authority and then asking us to appeal to that authority and then say he's not doing that? Sophistry, right? Disgusting. The way they get around talking about things. They just make up shit. And then tell you to go and talk to somebody. But guess what? You can't talk to anybody. Because there's a load of gatekeepers. And these guys are here to stop you from talking to people. That's their job. They don't want you to talk to mathematicians. Because were you to talk to a mathematician and say, can a tangent be tangent to itself without the need of a circle? What do you think a mathematician would say? Say, don't be fucking stupid. Who told you that? And you'd say, some guy on a Discord channel. He said you'd agree with us. As he was appealing to authority, as he was making shit up.
For them, I'm basically convinced that they will agree with me. They might not. Who knows? But I'm pretty sure that they will. That's all. I'm just saying what I'm convinced about.
Yeah, you're convinced that you can call a tangent a straight line and then say it's also tangent to itself. You can do away with the curved line with a tangent and have the same straight line be tangent to itself. That's utterly ridiculous.
Yep.
Yeah.
I think so.
Yeah, absolutely, yes.
Okay, but then I tell you that ask anybody else.
It
Anybody
breaks
who
the
knows about
laws
this
of
stuff.
non-contradiction instantly. Ask anybody else, he says. So I will ask anybody else right now. Does anybody else think that's fucking stupid? That you can actually do away with the curve and have a tangent be tangent to itself? Does anyone believe that's a new mathematical thing that Science It Out has just told us?
No, I think that it was bullshit from the beginning.
Yeah. Yep. Not many people in the chat there, but yeah, he's obviously bullshit and he's making it up. So the video's here. People can watch this. It's called B-Ball's Tangent to a Straight Line. It does have 400 views on this one. But I would imagine that if you want to see mathematical sophistry, then this is it right here. I don't think anybody else would ever attempt to do this sort of a thing. But I mean, hey, who knows? It might be right. Maybe we have to go to mathematicians with this. You know, who said it? Well, Science It Out. What's he sciencing? Well, I think he's sciencing the blue marble science. Maybe this only may be within blue marble mathematics. Blue Marble says there's nothing new about it. There's nothing new about it. So, Blue, are you having the tangent being a tangent to itself? The tangent line being a tangent to itself. Blue Marble Science. I'll get that. Put it in the chat so everybody can see that, just to document it. Thank you very much, Blue, for your ongoing support of the channel. There we go. I'll put it in the place there. I think that's enough of that anyway. It's getting late, isn't it? There we go. Discord. Okay, there's nothing new about it, Bev. It's been around forever. Try looking it up. It wasn't around in the Euclid days. So all of that old stuff we'll not bother having that as part of forever. Oh, there's Wiggles back again. Okay, how long's Wiggles been back for? Nice for you to come back and have a try. Where have you been? I measured the radius. Wow. Loads of people apparently. Radius measurements. I just bought myself a new compass today. I could definitely measure the radius of circles I draw. So well done. Well done for you, Wiggles. And Blue Marble Science saying there's nothing new about that. Does anybody else want to go over anything else? You reckon? What do you reckon to that? What does everybody reckon to the geometric sophistry?
For me, it is hilarious.
Yeah. But I mean, it goes to show you that these arenas that people have conversations in around here, it's full of people like that. It's full of people with science in the name. Always seems to be a bad one, doesn't it? You've got science in your name, or I don't know. Science it out, and I can science that, and Blue Marble Science. They're not really sciencey people, are they? I think they do that to make it up, right? To help them out. Wiggles, why don't you come in, man? Come in and have a chat. What's everybody thinking? You know, when you're watching it in the is everybody more impressed with the text chat than actually conversation? I find it much better when you can have a conversation and talk to people, but I guess, judging by what we've just heard, I think they're a bit scared of coming in. I've got some other videos I'm planning on doing for the rest of the week. It's Friday tomorrow. Got to go out. Hopefully I should be back in time. Maybe a little bit late. So I'll put my thing out as soon as I can. Right, so we are going to be going over these surveying methods that these people have done, but in order for us to understand how the surveying works, people really need to have an understanding of what horizontal is and how we measure the elevation changes reference to a vertical. And it seems to be a little bit tricky to when you're talking to a certain group of people. Now, I'm not particularly bothered about talking to, you know, these people that don't know what a horizontal plane is and all of that. But is everybody else sort of wanting to know how we do the surveying and how the operations work and any of the tests that we've done? Or are people more still confused about what a horizontal plane is and, you know, how we measure a vertical change from that horizontal plane established by a level? Are people still confused whether level is a horizontal plane, or how much more do we need to explain when we're doing this? Because soon enough, we're going to have to continue with the tests. But it seems like there are people. Can we say that there's a tiny little group of people that don't understand and that want to redefine mathematics? And we're just going to have to leave them alone to the text chat. If they don't want to come along and have conversations with us about how the realizing Euclid tests are going to be performed, how horizontal plane and how we reference the measurements to that geometrically in reality, and whether they have problems with it. I mean, because yeah, the blue marble scientists are a crazy group of non-realists. They're just out of their minds. They're in a group on their own. I don't think they personally, I don't think they make any sense. I don't see how you can, once you allow yourself to have these contradictions within mathematics, then you've got endless problems. Contradictions breed more contradictions. It's a never-ending chain. That's the reason that once you allow a contradiction within your logical system, you explode that logic to literally make anything possible by using the contradiction flaw that you've allowed into your logical system. It's that destructive. And I'm guessing a lot of people have allowed that to occur within their minds. Because this isn't something that just occurs on a piece of paper. Your logical system is what you derive to reason things for yourself. If you lose that, then you're going to be struggling. You're going to be a blue marble scientist. Dribbling in the corner, not wanting to discuss anything other than straight lines on spheres. Okay, so anyone got any final words or anything? I'll queue up a Buster song. I should really start structuring this all more, but that will happen in April. This is all for free, isn't it? And thanks for watching, everybody. Even though that we only have a small, loyal group of people, I hope not too many of you are triggered globers that watch for hate watching. I hope there are people that are genuinely interested, people that want to hopefully come and have a conversation with us. Anybody got any questions or anything like that, come and join us in the Discord server. It's the weekend coming. We're going to start the precious stuff. We're going to start talking about the Realizing Euclid test, part 2. Level Boogaloo or whatever. I don't know. That's going to be fun. We want more people to be involved in it. We've already got the basic outlines of it. We're also going to be writing the logic, the globgic, to help these guys out and how we can formulate imaginometry. We will be delving more into the imaginometry and how we did that. Comedy nights. And showing people how we can it may sound frustrating to listen to these people, and when you're in the rooms, when you go in to have conversations with people, you may get frustrated talking to these people, but like Paper said, once you learn a bit about this sort of stuff and how the different methods go, it becomes funny. In fact, it becomes even more than funny. It's hilarious that the sophistry can be exposed, and you'll find that blue marble scientists have no argument. They have nothing but sophistry, and I think they know it now as well. They know it. They know that they can't come and talk to us. They know that they can't present any proofs geometrically of their model, and it must be embarrassing for them.
Even someone may predict that if you are talking to a zealot glober, that would be a clown comedy here.
Okay, so we'll end up with the greatest speech. Thank you very much. Join us tomorrow. We'll be Free for All Friday. Pretty much more of the same. Don't know. Hopefully, if you want to come in, we get some blue. If any blue marble scientists want to come in, explain any of this geometry. Explain if there's any other blue marble surveyors out there that want to come and like try and convince us that Jesse Kozlowski might be a real surveyor. I doubt it, but I mean, it'd take a lot. If there are any other surveyors that want to come out there and explain to us anything really, then come in. It's free for all Friday tomorrow. Thank you very much.
You have the love of humanity in your hearts. You don't hate, only the unloved hate. To those who can hear me, I say, do not despair. The misery that is now upon us is but the passing of greed, the bitterness of men who fear the way of human progress. The hate of men will pass, and dictators die, and the power they took from the people will return to the people. And so long as men die, liberty will never perish. Let us fight to free the world. Let us all unite. Don't give yourselves to these unnatural men, machine men with machine minds and machine hearts. Let us fight to free the world. Soldiers, don't give yourselves to brutes, men who despise you, enslave you, who regiment your lives, tell you what to do, what to think, or what to feel, who drill you, diet you, treat you like cattle, use you as cannon fodder. Don't give yourselves to these unnatural men, machine men with machine minds and machine hearts. You are not machines, you are not cattle, you are men. You are men. Let us fight to free the world. You have the love of humanity in your hearts. You don't hate, only the unloved hate, the unloved and the unnatural. Soldiers, don't fight for slavery, fight for liberty. In the 17th chapter of St. Luke it is written, the kingdom of God is within man, not one man nor a group of men, but in all men, in you. You, the people, have the power to create machines, the power to create happiness. You, the people, have the power to make this life free and beautiful, to make this life a wonderful adventure. Then in the name of democracy, let us use that power. Let us all unite. Let us fight for a new world. A decent world that will give men a chance to work, that will give youth a future and old age a security. By the promise of these things, brutes have risen to power, but they lie. They do not fulfill that promise. They never will. Dictators free themselves, but they enslave the people. Now let us fight to fulfill that promise. Let us fight to free the world. Let us fight to free the world. Let us fight for a world of reason. A world where science and progress will lead to all men's happiness. Soldiers, in the name of democracy, let us all unite. Let us fight to free the world. Let us all unite. Let us fight for a new world. You, the people, have the power. Let us all unite. Let us fight for a new world. In the 17th chapter of St. Luke it is written, the kingdom of God is within man, not one man nor a group of men, but in all men, in you. You, the people, have the power. You, the people, have the power to make this life free and beautiful, to make this life a wonderful adventure. By the promise of these things, brutes have risen to power, but they lie. They do not fulfill that promise. They never will. Let us fight to fulfill that promise. Let us fight to free the world. Let us fight to free the world. Let us fight for a world of reason, a world where science and progress will lead to all men's happiness. Soldiers, in the name of democracy,